Thanks, Matt. No IPv6. No IPv6.
Where do we read that?
Na da unten, da in der Statuszeile.
Oder ist dir das anderes, mein Lieber? Ja. Dann würde ich auch bitten, dass du einfach dann schreiben jetzt. Ja, ja. Okay, hello? 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 Okay, it's working, that's great. Hello everyone. It's just a lightning talk, so it won't take long. So this is just some update on this MeshNet Lab project I'm writing on. Basically, it's some Python scripts that creates a virtual network interface to virtual network from some topology that is defined by a JSON file, and in this on this topology, I have like virtual nodes. I can run Batman, Babel, and such other routing protocols, and then send messages between those, like pings, well, literally pings. And this all works with Linux network namespaces. And I use it to create test scripts that start like 100 nodes, connect them in a certain way, adjust packet loss for some links, and then assign maybe some virtual coordinate of each node, and then let them move around in a virtual space, and if they're in a certain range, then I will create a connection. But what every virtual node sees, I mean, this is just like Batman instance or Babel started in a certain network, Linux network namespace, and they just see one interface, but the packets that arrive there just come from those nodes that are connected in this virtual space. And this is changing, so this is all mobile ad hoc. And the app that I want to do is has this idea to make a GSOC project to simulate satellites, like Starlink and stuff. But in the end, I decided to do it myself. And this is just something I wanted to show. So here in my GitHub project, I have test scenarios, and there are a lot of test scenarios here, and I just wanted to show you that what I've done. So if I go here, then you see also a nice view of those satellites. So you see like the orbits of nodes, so I don't know how many nodes, 250 nodes. Every time nodes are connected, you see the links. The Linux network namespace of that specific node on my laptop is connected to, the other namespace, and it changes over time, and you see these ground stations, Seoul, New Delhi, Berlin, Paris, New York. It's a bit messy, but maybe you see that the connections, every ground station has two connections to some virtual satellite, and it's getting worse if the connection is getting longer, and then it breaks down completely. And I can actually run Babel and Batman on that and do measurements and compare them. But the thing is, I've created these tests, but I haven't gotten time to actually run tests. I did some dummy tests and got some graphs, but nothing that I've created some graph from or something that I've stored. So this is still like to do. And let me just maybe start it. I mean, the thing is, the animation part and the simulation part are separate. So this is not, somehow my, oh wait, no, that's the terminal. Okay, let me run that. So when I run the simulation, then it's not simulating, it's not showing the animation, because the animation is, well, it's some Python package and it's a bit slow, and I really want to have the performance for other nodes to actually run. So, but this is actually how the connection changes in this virtual network. So I can zoom around and also zoom in, I think. Yeah. Yeah. And yeah, basically that's it. I mean, you see how, okay, the speed is a bit fast. Maybe you see the real time above, so it's moving quite quickly. But when I run this with Batman and such, then I notice that I have to slow not to have it too fast. I mean, if it's real time, that's no problem, because then the links are changing very slowly. But if I do it like 100 times faster than real time, then normal mesh routing protocols we use have some problems, or at least their implementations. And also I noticed, I mean, I have 3 satellite test scenarios here. Okay, that's loading. So this one is simpler. And I think this one is with packet loss and limited bandwidth to 20 megabit. And yeah, but the problem, I noticed when I introduce a low packet loss, then very many mesh routing protocols have problems, because you see there are lots of hops when you go from, for example, Seoul to Berlin. And of course, packet loss adds up quite quickly. Well, it doesn't add up, but it grows quite quickly, and that's pretty bad with most mesh routing protocols. But still, I have a few test scenarios where I test connectivity, and in different scenarios. So, for example, if one ground station pings another ground station, or yeah, actually I have to read the descriptions there, what is tested. But yeah, so that's what I did. So I haven't gotten around to run actual tests now to measure stuff, but I'm ready now to do that, and I just wanted to present it because it's quite pretty to look at. So thank you very much, and if you have questions, yeah. Okay. Oh, there's... Okay, maybe you can tell me, or do you want to have the microphone? Okay.
Just wanted to ask you, did you implement Linux container from scratch? Are you using Docker, LXD, or something like that?
Okay, that is a very good question. The thing is, the project started out, I wanted to test scalability, so I want to have a lot of nodes, like hundreds, thousands, and I have crappy hardware, at least for this kind of simulations. And so I decided not to go with Docker containers or stuff. What I use, I mean, you all use maybe the IP command on Linux, IP address, and then you list all the interfaces and addresses of your computer on Linux. But you can also use, and that's what I use, IP netns, stands for network namespace, and then you can create one with a name, and then you can use IP netns exec, and then execute an arbitrary command or a mesh routing program, and it will then only see this specific namespace. So it will see not the interfaces of your actual computer, but it will have its own IP stack. And in this network namespace, you can put interfaces and connect them to other network interfaces. And yes, that's what I do. So, but all these programs see the same file system, so it's only the IP stack that is different, just to save as much resources as possible. I hope that answers your question. Okay, it does. Great. You have another one. Okay, let's go.
So my understanding is that you are interconnecting the network namespaces through virtual Ethernet, VATH links, or something like that. And how do you simulate packet loss in that case?
Okay, first question, answer is yes.
Okay.
Second question, how I simulate packet loss. I use a traffic control command, TC, that many of you have probably seen, and I can use that to add packet loss, jitter. I think is also possible. Limit the bandwidth. Yeah, of course it's a performance hit of on the whole simulation, but if you want to have that, you can do that, and I do that for I think this simulation. Okay, more questions maybe. Okay.
Can you just repeat what you said on simulation time and real time? I didn't really get what the idea was. Is it that the routing protocols still have their usual timeouts and stuff, and you're just doing more rerouting events than could happen in real time?
Okay. I mean, this animation runs like 100 times faster than real time. So these are low Earth orbits. So I don't know how long it takes. So maybe 1.5 hours. But if I really run the simulation in real time, and then it would run like maybe a few hours for the satellites to get around the orbit a few times, then mesh routing protocols don't really have a problem with that, because that's quite slow, and the connection are not changing a lot. So to make it more interesting, I speed up the connectivity changes. So basically the real-time connectivity of the satellites there. I think 50 or so is something that 50 times faster than real-time is something that the mesh routing protocols that we use, Batman, Babel, BMX, and OSR, have no problems with their default timeout settings. And I did 100 times faster for this animation just because it looks more interesting.
Okay, so if I understand correctly, you leave the routing protocol as is and just increase the number of rerouting events that occur. So if, for instance, you have a routing protocol that does connectivity checks every 5 seconds, say, and you are running it at 100 times faster, then it behaves as if you are doing the connectivity check every 500 seconds instead. So you're not changing the routing protocol's time constants, or do you change them?
The answer is simple, yes. So I do not change the timings of the routing protocol. I leave the defaults. I do not play with that. Instead, I just speed up the simulation to have more connectivity events.
Okay, understood. Thank you. And I posted the link to GitHub in the chat already. I didn't look very closely at it. Is there a way for contributing that you prefer? Any hints for people who want to add stuff to your software?
If someone wants to add something, please feel welcome. Just make a pull request on Git. Of course, you can get into contact with me before. This is mostly a project I did for myself, because I want to play with routing protocols, and I want to have routing protocols that's routing algorithms that scale for much bigger networks that we currently have. And for that, I needed a test environment to test that. And so I wrote myself an overblown simulation. Contributors are always very welcome. I mean, many of the tests I have their test scenarios need maybe a bit improvement. And I hope maybe next year at the Battlemesh I can present actual results. I already did that once, but not with these satellite tests. Okay, there's another question.
Thank you. Do you think you will ever need an interference model for these simulations? Like when links are somewhat interfering, do you think?
Interference patterns are, of course, interesting, but I have to say I don't have the resources to do that. It's quite complicated. I don't know much about it. So I completely left that out of this simulation.
just doesn't go off. Einschalten? Muss man lang draufdrücken.
Okay.
Yes, perfect. I mean, do you know a little bit about the current networks? How
Yes.
these links, are they ever interfering or not, or something like that? What is publicly known about these networks? Also on the protocol level, do you know some?
I do not know. I mean, I've read about interference, but I can't recall any specifics. I know with packets there can be crazy stuff happening in terms of interference, but it's not anything that I take care about, that is in scope of this project right now.
But do you know on the protocol level?
On the protocol level,
What do they use internally?
I do not know. I mean, of course, if a package is trashed, I guess that's something on IP level or even lower that is handled. I don't know what, but I think the Wi-Fi driver, of course, has some collision avoidance and detection. So you can be reasonably sure that either the packet is received and mostly correct, or if it's not received officially.
Not only interference, I mean, also on layer 3. How do the commercial networks route, for example?
Commercial networks. You mean on the wire or Wi-Fi? I don't know. They handle
The satellite networks that are out there.
Okay. You mean satellite networks?
Yes.
I also don't know.
Okay. But somebody here, maybe? Or maybe we can call Dave, Tat or something?
The only thing I did with satellites is that the connectivity there, how it changes, is according to the position of satellites and ground stations, and the packet loss and such is modeled very creatively based on the distance of the connections until the connection is entirely broken and yeah.
I think that if you want to simulate the channel, so the interference, when you speak of layer 1, I think that you have to use network simulation 2 or other software. If, for example, if you use Core, the simulation named Core, developed by American Navy. For example, use the same approach for layer 3, so it uses namespaces, but you can interface with the channel simulator. So you can use to connect to NS2, for example, this is one network simulator or other stuff. So I think that this work only on layer 3.
Okay.
Okay.
Well, what I simulate is basically layer 2, but for actual satellites, I don't know.
Yes, but the layer 2 is virtual Ethernet.
Okay.
It's a dummy transport. So you don't have the simulation of the channels, of the satellite, of the Wi-Fi, of the other stuff.
I just want to say, I like this. I mean, we're slowly moving into space in Battlemesh now, I have the impression.
Well, actually, the motivation is, I guess the motivation was that it's going to look pretty, and I succeeded.
It looks nice.
And also that it's just interesting topology change.
What made you start doing satellite?
I guess everybody watched Starlink and stuff, and I thought, okay, Starlink currently doesn't use mesh networking at all. It's only...
It doesn't?
No, it does not yet.
We know that for sure?
I'm rather sure, yeah. From what I've read. I mean, I've looked up data, maybe...
Are they watching right now?
Sorry?
Are they watching the stream right now?
I don't know watching this stuff. Well, I do not...
Call this guy if you want to know.
As far as I know, Starlink, all what it does is... there's some ground station, signal goes up to the satellite that is currently in orbit there, and then the signal goes down to the consumer. And currently that's all what they do. But in the future I think they want maybe some multi-hop stuff. maybe Hauke knows.
I read an article some days ago that they now had some connection in Antarctica, I think. And they said that it's only possible if they had the inter-satellite communication. So it seems to work sometimes.
Yeah, maybe they have changed something recently.
I think they have some satellites which have these inter-satellite links already working. But I don't know if they use mesh or just configure statically or whatever would they do.
Yeah, nobody really knows for sure. I mean, there are a lot of papers that discuss how you can do meshing there. But what they actually do right now, I don't know. But until recently, at least, they didn't do any multi-hop connections there for consumers. Yeah. Okay, so Hauke again.
Linux has a time travel mode. You can use it to do if you have with your timing. So what we discussed before, this is this 5-second timeout. I haven't used it. I think they use it for the host APD and Wi-Fi testing.
Okay.
It allows it. As far as I understood it, that in users when you use user mode Linux, you can configure it like that. If it's waiting for something, it's immediately happening. I think somehow make it also that the CPU time is constant, so all computes are irrelevant for the timing.
Okay.
Well, I haven't used it. Maybe it's interesting.
Yeah. I mean, in the README of the project, you might see that I have some notes there about modifying the time as a to-do. The thing is, when I try to simulate networks of thousands of nodes, then my computer will just say, yeah, everything is 100% CPU usage, and of course this has a very negative impact of the whole. I mean, basically, I'm measuring the performance of my computer in the simulation and nothing really with the routing protocol. And I thought about just maybe letting the time of the whole applications run slower. So maybe the routing protocol will well, basically that I can run 1 minute of time in the routing protocol as 1 hour in real time on my computer, so I will have more performance to work with or something. Well, but I don't think it will work.
I think this mode will support this. As far as I understood the documentation, it's supporting this mode so that all compute for the simulation takes 0 time.
Yeah.
And when it doesn't matter if you have a very fast machine or a very slow machine. So it's all these, it behaves always the same.
I mean, tell me more about it, maybe afterwards. I'm eager to try it out.
Just read the document while you were talking. Documentation, so not more, but talk.
Sounds interesting. Okay, so if there are no more questions, then I'll just say thank you and have a nice day.
So let's say
you have to sign this bunch of papers. No, we just recorded in the
blockchain, yeah.
Are we ready? Should we invite everyone?
Yeah. Hello. Do you want to come to the next talk?
You should and say
Okay.
1 minute early.
Yeah. You have the 3 gadgets from the tours.
Very first question. If we set the rules with the IP tables and EV tables, will they work?
Sorry?
If we have the rules set with EV tables and EV tables, will they still work with OpenWRT22 or we have to replace them to NS tables?
So it depends. So so there's a compatible layer for which allows to use the old IP tables and so on interface, and it then actually does NF tables. So it's also
Wait, converts.
it converts. It's also the default thing for I think when you use Debian or more or less every desktop or server Linux distribution. You are using IP tables command. What you actually do is NF tables.
Okay.
So even my Debian stable.
Thanks.
So let's wait till everyone, or I think there are still some people moving out behind that. Yeah, there's still some people coming. Okay, I think we can start. I was asked to give a talk about OpenWRT, the new stuff in the releases, in the recent 22.03 release, but I didn't really have the time to prepare a talk, so I asked if you can make it a Q&A session or discussion. So therefore, this is not a real talk, but more a Q&A session. So I didn't prepare much. So I have the release notes, and so then, so I can go slightly over the highlights of the release. Probably most of you already read it. So we have the biggest change is now that the old firewall system is replaced with this firewall 4, which is now based on NFT tables instead of IP tables. So the background is mostly that when you look at current Linux distributions, so even my Debian stable, it's using NF tables by default, and also the Red Hat and so on. So IP tables is not much used anymore. So even when you type in IP tables and do something like that, mostly you are actually using NF tables. So there's a transparent, so the NF tables guys implemented a CLI which behaves the same as the old IP tables CLI. But with Firewall 4 it uses real NF tables and is rewrite based on the new U-code implementation, which allows us templating and such things. So Joe did a great job and more or less invented a new language. That's so the UCI interface there is compatible. So if you have in UCI some old firewall configuration, they still work. If you have custom rules, then this needs some adaptations, maybe. There's some part with the took some time, but now I think we have most of it. So there are still probably some problems with some packages in the package feed and so on, which are not converted. So we had to migrate all this stuff. So I think the important stuff is migrated. The rest hopefully gets at some point in time. When the standard thing like new devices. So there's always a pile of new, so mostly from external contributors. They have a new, some company makes a new device, someone wants to run OpenWrt on it. So I counted it, at least how many devices we had in each release, and we had there 180 new devices in 1 year. And like the standard things, so like we have more targets migrating to DSA. Probably next release there will be additional targets migrating to DSA, and I don't know, probably we will get rid of SW config when the last devices are getting, probably it takes multiple years till this is gone. Dark mode for Lucy, and the device will also work after the year 2033, so I hope that you all upgrade to something more recent before. But probably there are some vendors which are using it. So we have when the Unix timestamp is overflowing. So if you have 32-bit systems and want to operate them longer than 2038, take care of this stuff. And standard updates. So do you have any questions, or do we want to talk about it? We can questions from the audience, or can we make a discussion out of it?
If I do the upgrade, is it better?
So can we? Okay. Let's do it with a microphone. It's working. Yep.
If someone is running a 19 version, should he upgrade to the 21 and then the 22, or is it directly possible or better version?
So it's off. Okay. It's officially not supported. It's officially not supported. Maybe it works.
If you say minus n, like don't keep the configuration, it should
then
work,
it should
right?
work, yes.
Okay.
So I cannot guarantee.
So when you see supported, you mean keeping the configuration.
Yes, with keeping the configuration, except if you have DSA and DSA migration in between.
Okay. And can we ignore that warning message? Like, can we always put -f, like, to force a sysupgrade if we ignore all the configuration? Like these error messages saying image 1.1 and device 1.0.
Yes, this is only about the configuration, so you can, if you force it, you can ignore it. Or I think there's the -n is, I think, the configuration.
-n and -f uppercase.
But then it will not migrate your configuration. So
but
if
that's
you don't
okay.
care
But
about
if we force it and we don't keep the configuration, there's no risk to break the router.
It depends.
Depends.
For this reason, it will not break your router, but this mechanism is more generic than just for DSA. So sometimes the version changes because you can break your router, so you have to be careful.
So this is about configuration, so it probably makes sense to read it before. So when you have it automatized, you have, for example, 200 of the same devices out in the field, then you should try it on one of the devices. If it works, then you can. So it makes sense to try it if you want to do it.
And in the same way, it's okay to downgrade from a DSA to an image with SW config?
Yeah, that's not supported officially, but should work sometime, mostly.
Okay.
So this is always the supporting all the going around. So normally we try to support it, but I cannot guarantee it.
No, but if you forget, if we just ignore all the configuration, it should work.
Yes, yeah.
Okay, because this warning message is very scary, and I didn't know how much seriously should I take it.
So this is this specific warning message is about that the configuration model change.
And it appears also if you put -n.
Okay.
So that's why I was scared and didn't understand what was the risk. Thanks.
Yeah. Okay.
So basically, it's a hack. It's just a hack to show you a warning message. Maybe to explain more, so there's this image version mechanism that so the goal is to make sure that you don't accidentally upgrade your router while there is very breaking change. I don't know, bootloader change or whatever. And it was used maybe a bit as a hack to display this message for DSA configuration.
Okay.
Yeah. I think because there was no mechanism to warn about this just if you put -n. Yeah.
Yeah, so
I agree, it can be a bit confusing.
It's a bit different because the
Yeah.
when you use the DSA, you configure the trunk, the untagged on a bridge instead directly on the switch. So it's a bit tricky because if you, for example, I present this on my presentations, but using the switch config, you work directly on chip, okay, with the configurations. When you use the DSA, the configurations is in a virtual switch that is a bridge between the port on the switch. So everything happen in the CPU and no more in the switch. So I don't know how it's possible to migrate from switch config and DSA configuration. It's a bridge. It's called the bridge filter, like that. So, yeah. So I think that is no easy to migrate the switch configuration from switch config to DSA. I present later about this.
You want to say something about this? We talked about this.
There might be plans to automatically convert switch config configuration to work with DSA interfaces. That's the plan. I think there's an opening on 16 to 16:30 tomorrow. Maybe we can make a presentation at that time.
So when do you want to present? So you also have a plan for...
Later.
Okay, later today. Okay. Yeah, it was... so regarding the migration, it was always... We wanted to do it, but nobody really came up with making our script to migrate it, so it didn't really happen. Anything else? Yeah?
So when I read the release notes, I just was really happy that you did finally the switch to NFT. So that's really nice, and also that now switch config is gone and you're doing the same that everybody is doing was also kind of good to read, because less own developments and more community together developments sounds good. So,
well,
pretty happy.
There are multiple advantages. So, for example, now with the DSA, we really benefit from the guys adding switch support for the Yocto systems for some SoC, and that's then also working in OpenWRT. And they also get our stuff. And I think when we started with SW config, there was no real hardware switch configuration mechanism in Linux. There was, I think, DSA is already pretty old, but it was more or less to just talk to the individual ports, and I think the bridging and VLAN configuration is new, so seeing 8 years of, I don't know. And for the NF tables, it's also, there's much more development going on, and also the hardware offloading. For some, the routing hardware offloading, I think it was only working with NF tables and not with IP tables, so we had a hack there, and that's then not needed, so we are also then closer to mainline, which makes it easier to develop when there are not so many hacks needed.
So also a mean question, when does the next release happen?
I don't know, it depends. So I think the plan is, so if it works in a year, or I don't know, it depends on how much time people have and so on.
Hi, I know that the support for 4 megabytes of flash and 32 of RAM was dropped since after 19 release. I don't know if anyone tried it with 29 or 22 and above, because we have plenty of 8 megabytes of flash and 32 megabytes of RAM devices running, and I don't know if there's a specific configuration to reduce the amount of RAM, maybe getting rid of Lucy interface and a lot of stuff to make it work with 22 and so on. Anybody tried it?
I opened the bug report for a Pico station that I tried, because with the normal image downloaded from downloads.openwrt, it just did a boot loop. So the old question is also, which I also raised in the bug report, or in the issue as it's called, do we even want to publish images that are known broken? But on the other hand, there would be needed some tests to know that they are broken.
Normally we try to deactivate the building of these images, so there's an option that it's still there, so when you manually build it, you can build it. With Lucy and the TLS support, the Wolf SSL which you need for VPA3, maybe it's working then, so it makes then sense to have it in there, but not build the default images, so that's possible. We have it deactivated for many devices already, especially the small ones, so it would be nice to just deactivate it. And yeah, for the 32 megabytes RAM, it depends, so if it's working for you, so it depends, so it could be this case, like that it's in the boot loop that something doesn't need, that something needs more RAM. So yeah, it depends, so we have to, someone has to check it really on the device, so if you want to add it, if it's, yeah. So if it's boot looping the default images, we should not build them and not publish them. But if it's stripped down image would work, then I think it's fine to have it in.
So can you say something to that? Can you say something to that? So that's why, also we have also tested on all this ubiquity non-station XM stuff and so on. And the kernel had some issues because it was so big as of the image. So that's why I put everything to this tiny image of, for example, for ALTH79, and that's actually working great now, and enabled the low mem flag. And now it even works with 5.15, the kernel, and with this mglru.
Yeah, I think this low mem flag and low flash flag and also some features in the kernel are getting deactivated. So then you cannot run containers on it and this stuff, but probably you don't want to do it anyway on this Untitled device.
How should I run the kernel? It's 380 megahertz.
I think that's not the limiting factor. It's probably the 8 megabyte of flash and 32 megabytes of RAM or whatever you have. That's probably the more limiting factor. The other one makes it just slower. But there's on the other side, there are lots of devices now with non-flash, where you have in 128 megabytes of flash and you have in the 256 megabyte of RAM or even more, or people using Raspberry Pis, and they want to run some containers on it. So yeah, but yeah, this low mem, I think this low flash makes it use more DDR, but I'm not exactly sure. I think there are some settings that you change some block sizes for Squash FS, which make it use more RAM. Anything else?
Why did it take half a year to finally release?
Oh, there were bugs in there. And yeah, it's when the thing to, yeah, first someone has to start doing the branching off, really find, okay, we are now fine with it, the quality, then you find out that there are lots of bugs in there, so from the reports from the community, so it really helps to be people checking their RC releases in their environments, and yeah, there was, with the new firewall 4, there was, yeah, some use case didn't work or were broken or whatever, and yeah, getting this all fixed when there was some, I think the latest was some problem in the driver for the MediaTek Wi-Fi devices where wasn't working. You couldn't, after some time, some people couldn't reach do SSH into their boxes because as soon as there were DSCP bits set in the IP packet, this was all dropped or something like this. And drop here now makes it priority the packets, and yeah, then it wasn't working at all anymore. So there are mostly bugs getting fixed, and then people having no time or doing other stuff. And the initial, so starting this, so we started with it, that was mostly the kernel migration, and this was finished for all targets. So that could probably be also for the next release again problematic, I think. Many targets don't even have a pull request or anything for kernel 5.15. So most of these targets are probably not so popular anymore. Maybe we delete also something of these.
Hey, I wanted to ask something. Is this the first time that OpenWRT is releasing a new release only after 1 year, right?
Sorry?
Is it the first time that we start releasing every year?
Yes, more or less, yeah.
How did it go, and do you think it's sustainable for the future?
I don't know, it's a lot of work and someone has to do it. So that's the most, this is the problem always. So we had initially, I think in Hamburg, we decided to release every 6 months. Yes, and at least now we got something working to do it once a year. I hope this, will go on. I don't know. It depends on if enough people have time to do this and manage this and so on.
And do you think it's good?
I think it helps the community, because when we get new changes faster to the community, especially new device support and so on. But sometimes, when the last release was 2 years ago, when most of the new devices were not supported.
Have you thought about a release schedule that accounts that some releases may have more backward incompatible changes, and then some more long-term support, stuff like that?
There's not really a release planning going on, or at least not really feature-wise. So it's more or less at some point in time we say, okay, master looks fine now, and let's do a new release, and then the stuff which is in there gets released. So for the last release, it was mostly we wanted to migrate all, so we want to have all targets on the same kernel version. We did it on an earlier release where we had 2 kernel versions, and it was a lot of extra maintenance work. So we tried to get it all onto the same kernel version. And for the rest, it depends on what is there and what's the maturity. So for the 2203 release, it was mostly about Firewall 4, if that's now mature enough, and there was some discussions, and then we activated it. So there's no real plan on what should be in the next release, except I think at least kernel 5.15. So I think otherwise
So for the next version, the only goal right now is the kernel upgrade, or is there anything else?
Yeah, probably, but that's at least what more or less the people agreed on, and the rest it depends on what is there. So if some of the new features are stable enough and make sense to have it in the default things, then it's there, and otherwise not. Otherwise you have also all the other things which happen in master, so there will be a lot of new devices be supported, but there's no decision or gating or something like this. This is just, stuff gets added to master, and at some point in time the release will be done. That's more the development model.
Nice.
So the release notes say that there were lots of updates to core components, like muscle and glibc and stuff like that. Is there something that you learned that might be interesting to application developers, other developers working on embedded platforms, that's relevant to mention?
I don't know if how relevant it's to mention. At least some people are interested in this. So we have to upgrade this stuff, otherwise we run at some point in time into problems. So we had some years ago problems where I think we had GCC 4.9 and it was 3 years old, and then the U-boot for some Alvina chips didn't compile with it because it needed GCC 5 because that generated small enough code to fit into the SRAM or something like this. So at some point in time we have to upgrade this stuff. Depends on who is interested in this. So currently we have, I think, a pretty recent toolchain again. So there are different users of OpenWrt. There are the users who just download this, put it onto their device. There are people using it as a base for their own things. Yeah, when we release notes, we put what we think is more or less interesting and what someone wants to write about. Anything else? So what should we do different? What should OpenWrt do differently to better work with the mesh communities, with the v14 communities, and so on?
What from my perspective comes in mind is getting a stable master, so that master or main is never broken. So you could even use OpenWrt as a rolling release model. That would, I think, be a good thing. Yeah, regular releases are always nice, but on the other hand, keep it working, keep it maintained, so we can do great stuff on top of it.
Okay. So we try already to keep it that master always works and that there are no. So for sure there are bugs in there. So when you change something, you make some mistakes. You cannot prevent it, and but we try to keep it always working. And also when you do your modifications, contributions, so if you are 3 versions behind, then it's harder also for you to contribute back. So it would be nice. Yeah, also from our perspective, it's nice if you, I don't know if your development branch for Gluon or whatever uses master, then you can easily sync with things or whatever you use. Yep. Or someone else? Yep.
Can we put the question the other way around? Is there something where the community can help you more, other than just running the software and then at some point in time coming to complain that stuff breaks and doesn't work and how dare you? So is there a way to involve the community more in testing or in specific, I don't know, tasks which might lend themselves to be decentralized and outsourced from the kind of core OpenWrt community?
So for my testing is always interesting. So also that you test master. So when you report bugs on now on 21.02, I'm not so much interested anymore. I see, okay, we declared end of life in 6 months. So yeah. So I'm most interested when you can report bugs in master that something is not working. And yeah, in OpenWrt, so currently there's some bottleneck with reviewing stuff and so on. So that would also be helpful if also other community members, other people try to help reviewing the pull request on GitHub or on the mailing list and give comments. So it's much easier. I think this is also a task which can be easily outsourced to everyone.
Yeah, so I've already done it 1 or 2 times that I just saw a pull request, and even that I'm not involved in it anymore, I just read it, that looks good to me, or there's a typo somewhere or whatever. This already helps,
yes.
Because one thing is it puts it on the top again, more or less, because it's got interaction, and also if there's a typo, it can still be fixed before it gets committed.
Yes.
And yeah, do more review.
Yes, yeah. So when you complain that your patches are not applied in time, it helps you, then you also review the other patches.
Review your own patches. Did I understand that correctly?
Sorry?
Review your own patches.
Yeah.
I was going to ask something very similar, like what are the time frames in which you would usually expect feedback, if any, or is there like a feedback channel once you submit something? It will take at least 6 months until someone will say, "Oh yeah, I realized it's there. Relax, we'll take care of it later," or something like that.
So my personal strategy is now that I, in at least on GitHub, sort of the pull request by last update, and then go from top to down. So at least that's the ones the activity is going on. And yeah, often which is then 2 weeks no activity. That's then the end of the. Somewhere at that time, yeah, normally I don't look much when the day is over or whatever. So that's my current. I don't know how others handle it. Or for some tags which I'm interested in. So sometimes we look for what is there on the Nantic tag, also on older things. So, but mostly when I see the activity on the pull request, then I look into it. And yes, I think the time it takes to get something accepted is too long currently. This should be improved.
Is there a wish list on your end where you say, "Oh, gee, I wish we had more reviews on that specific topic"?
Yeah, it's I think general. So we have a lot of devices being added, and there's probably a review also not so hard because it's mostly the same stuff or similar stuff all over. Yeah, otherwise somewhere where you have some knowledge. So if you did something in UCI and you see a UCI fix or feature and think, oh yeah, that looks good. I look at the code and yeah, say, okay, that looks good to me. Or here there's some like the typos or other bugs, or if you just here what is this doing? I don't understand this. Just ask it. So if there's some interaction and that makes it then easier for me also to when I don't have to do it or someone else. And so that's I think the easiest way to offload where the bottleneck we have currently with patch review.
Yeah, you talked about this version upgrade of the kernel to 5.15. I also saw that, and I was asking myself, so why? So a lot of targets are not so like all this MediaTek stuff. It's directly lifted to 5.15 kernel, but there are some targets I never heard about, and also looked at those devices, and there are nearly no devices like in this makefiles. Are they still maintained, or is that actually the blocking factor, so that it does not, so you cannot release more often, or?
I don't think so. So there were some targets which are not really much used. I think this, what is this, Pico piano station, or this from MediaTek, from Imagination, some board. I think there's one development board for this chip SoC I'm aware of, and I don't know, I think I have one, but it's really blocking, so if it's really getting hard to update this, I would just, so there's always the discussion about the things which are not getting onto the recent kernel, if you just delete it, just remove it.
Yeah, I recently saw also some comments that just write, okay, here's a kernel bump, but it's only compile tested, not run tested.
Yes, yeah, I also did this some time ago, and then if there was no response from anybody testing it, then I think we just removed the target, and nobody complained.
So it's more like not a technical, so you don't release more often because of technical stuff, it's just a decision in this community.
Yeah, the decision, and it's you have to manage this, so do the actual tagging, triggering the releases, then running, getting an overview about the problems, trying to fix this, or getting people to talk to other people to fix it, and getting the overview. So there's a lot of work also involved in this.
I was thinking of one thing that could be useful from OpenWRT side was to make some public some statistics about like the downloads of each image. Because I was thinking, is there? I didn't see it. Okay, that's great. Because, for example, today some people were asking me which device would you suggest for point-to-point links. I was like, I don't know. I'm updated to 2010, so it was not easy for me. But if it's already on the website, that's great.
Where's this for downloads?
Like something like some way to see what's actually the best option to use. And the statistics of downloads will just do fine.
So there's the download statistic page.
Can it enter in the page of the tech data so that is more visible?
So now I found it. I don't know if they're only listing the top 100 images which were downloaded.
Okay.
Can probably make it bigger.
Okay.
So that's from the last month. Yeah.
That's very good information. It would be super nice to have these in the table of hardware, so you can like filter for like the bands that you like, the year of release that you like, and then sort them by these, and then you see the most used hardware, and you trust that.
So I don't know if it's really the most used hardware, it's the most downloaded images.
Yeah, it's
so it could be that someone has the script
yeah,
running.
it's the best that we can see, right?
Yes, yeah, and I think it's also only from the main download server, so if it's from some mirror and so on, it will not show up here.
Wow,
so just the statistics, I think it's auto-generated from the logs of the web server.
Yeah, it's not bad.
Look like real data.
Yeah, too less.
I think if there's a snapshot of one device, mostly at the top, and then next to it 1907.
Yeah, like I said, there may be some scripts running by some people who, download something, and that shows up here. So at least that's the data we have currently. So
I still think it's better than nothing. And another thing that I was wondering is there a suggested way for the communities to propose something that we would like to be included? For example, earlier TXT file told me that in ATH9K there is an auto distance setting, but you can't have it with the official image or the image builder because you have to activate it in the build root. Like, how is the suggested way for a community to annoy you until when you add it?
you can send a patch to the default and or GitHub pull request and put the disadvantage. So like probably the disadvantage is that it's getting bigger, and the advantage is you need it for your community. And
Yeah.
So if it says okay, the image, this module gets now, the disadvantage gets now 0.5 kilobyte bigger, and but we use it for our community to make long distance links work and so on. I think then it's okay to add it. If it's then about this image now gets 0.5 megabyte bigger, then
Okay, got it. Thanks.
Also a question for mesh stuff. So I never understood why Gluon is actually making such a own thing. Like they have their own. So a lot of Gluon developers are also in the OpenWRT community, I think. But they have their own packages feed and also maintain a lot of downstream patches, I think. So we're not using Gluon, but why is it like that? Never understood.
Can someone from the Gluon developers answer this question?
From the LibreMesh side, you have to see that we are also super guilty on that, and I think it's because the developers are just lazy for waiting and pushing to the official repositories, and they just push to their repository because it's faster. At least from our side, I think it's laziness.
Yeah, I guess some things are managed downstream, like the auto updater, because it's quite specific to Gluon itself and how the configuration and things like that look like, and it's not generic enough to use it for any OpenWRT use case at the moment.
But I think other than that, people like NeoRadar or Blocktron, they try a lot to get all these changes into upstream. So yeah, I guess that's why they're also working on OpenWRT directly, and yeah. So I'm not sure if it's really so much which we have different. If there's anything in particular you think like, oh, that should also be available for other people, let me know, then we can check if we can do something about this. And,
So also this changed in the recent years already, that it was worth before and nowadays it's put upstream as much as possible. But in between we had some, for example, Gluon had support for some devices that were only available in OpenWRT or master, but a bunch of communities already use them because with good availability. So then the stuff was backported or was put in Gluon first and then sent to OpenWRT because yeah, here there are 50 devices already tested, get it? And please make a next release, would be nice so we can use a release again. So otherwise the Gluon packages are really packages that are essential for Gluon, and as soon as it's not that's interested by a broader community, then it's normally a push to upstream or push that it should and could be upstreamed.
Yeah, OpenWRT has the same problem with the kernel, so the kernel relationship. So I think it's also improved, so that we still have lots of patches downstream which are then OpenWRT specific. Some of them are not in the quality that they can go upstream, or upstream this has to be done differently or needs major rework. But I think it improved in the last few years, so that it's closer to mainline Linux kernel, and so the biggest chunk of patches is now backports from more recent kernel versions. Yeah. Do you have a question?
No.
Okay.
I'd like to say one thing actually, especially on the RAMIPS target. We have this problem with mainline. Mainline maintainers basically say that the Ethernet driver cannot change the interface name for the Ethernet interface of the SoC. But on RAMIPS target, we have a specific patch which allows this. So you just put a label property on the device tree for a device on the GMAC node, and you just say label and this, and that interface will have that name. So this change, this patch, is literally just 2 lines of code, just 2 lines. But since the mainline maintainers does not accept this, there's a problem mainlining the device trees that they're on OpenWRT. Now I can't put that label property there because it's not going to work. They're not going to accept it. And now you have 2 ways you can go about this. You're either gonna put the mainline the DTS without the label property, and then put a custom patch on OpenWRT for each device tree. That's gonna be a lot of work. Or you're gonna find a way on OpenWRT SDK to automatically change the interface name to whatever you want. So, which way would people, maintainers of OpenWRT, go in this way? Would you like to make a completely new section on the SDK which would change the Ethernet interface name after the system boots? Or would you rather just make patches on the device tree on your own thing, which would give more downstream patches?
Is this rename needed? So I'm not really aware of this problem or feature. So can we get rid of this rename so that we use the default names like upstream kernel would use? What is the problem there?
The main motive is ubiquity. Likes to do things differently, right? Instead of naming switch ports like LAN or something, they call each one ETH0, ETH1, but they're not Ethernet interfaces. They're switch ports. If it was to be an Ethernet interface, it would be the Ethernet interface of the SoC. Since you use DSA, that creates an interface for its switch port, but they're still not Ethernet interfaces. Technically, they're Ethernet interfaces, but they're slave interfaces. The master is the main Ethernet interface of the SoC. So since Ubiquiti does that, and the GMAX 0 node is supposed to have the Ethernet 0 interface name, but there's also a switch port called Ethernet 0 now. So what are you going to do? You get my point? So basically, what is done is that 2 lines of code change that I talked about, that patch is brought, and the master interface is renamed to DSA instead. It's the interface is literally called DSA now instead of ETA0. And then switch ports are given their names that Ubiquiti has decided, ETA0, ETH1. So this is one of the problems with the RAMIPS target. So what are you going to do about this? You can do either more downstream patches to change the device tree back to your way, or you could just make something on the SDK which would just change the interface name after the device boots, which I think would be a proper way, and you would mainline a lot of device trees, so you could also benefit, like anyone else that does not use OpenWRT would benefit from having the device tree on the mainline, so they could just compile a kernel image and use that device tree to use the latest kernel version on their systems, on their devices, with their own custom file systems, which is like buildroot is what does these sort of things. So that's my question. Are you gonna downstream more patches to fix this, or are you gonna create a new section on the SDK? Like, I mean, I know this volunteering work, so it's not like we're getting paid to do this. So yeah, that's my question.
Yeah, I think for this seems to be, but there's then also a bug now in the upstream kernel when you want to add these Ubiquiti devices, as far as I understood it, because normally the DSA rule is that the interface name should be labeled like it's on the sticker on the device. If there's a conflict, I think we have now a bug also in the upstream kernel. Maybe we can convince them with that thing that mainline kernel is broken with without this label property. I don't know if you put the label property if it's on the device itself or if it's better placed somewhere in the generic network subsystem.
I think that would make more sense, yeah?
So if it is a generic network subsystem thing that, like for DSA, where you can also define the interface name.
On DSA, they specifically said that because of some reasons, legacy reasons, that it's allowed to put a label node on the DSA ports. You can just make it on device tree, but for not Ethernet drivers, not for Ethernet Max.
So I don't know exactly what is now the best solution for. I would really like probably to get this fixed in upstream, but if it's not possible, I don't know how to go forward with it.
Yeah, the best solution is like somehow change the interface name after device boots, doing something with the OpenWRT SDK. No idea, just had to be thought out.
Yeah, that's yeah. I have to look closer into it, so I cannot really give the optimal solution now.
Yep, that's it.
But there's often, yeah, we struggle with upstream kernel, so we have some strange problems, and yeah, when we have just a workaround for it, or the kernel wants to, the upstream kernel guys want to have it in a much more complicated way, or a way which needs much more RAM or flash or something like this, and yeah. Anything else? Yeah?
I was looking at the donate page. I mean, this is a little bit off topic, but I don't know if there's another talk. If there's another talk, then you interrupt me.
No,
okay.
No, you can ask.
About the donation page of the project, it's strange. I mean, there are like, for me, it's not very clear how much donation we have. I think that the more donations we have is better, and for me, it's like incredible the kind of services the OpenWRT project has, and I think this should be more highlighted. If we have more donations, maybe we can have better infrastructure for everything, and I don't know if this is For example, in the donation page says paid privately. That means that this person's paid that machine, or
Yes, yeah, it normally means that this person pays from their own funds for this machine. So it's more or less we have currently problems organizing this stuff. So we have some money, and we have also an organization representing us legally, which has also manages the trademark, our account, and takes care of the donations and such things. Yeah, but yeah, we are not so good organized. So it also needs some to get. So there's currently some work going on to get organization account at Hetzner, for example, because we have lots of infrastructure hosted at Hetzner, because it's not so expensive. And getting there, yeah, with this paid, with funds. But that's we have this plan since some time, since multiple years already. So currently the biggest problem there is our lack of organization mostly. So we have some money there, I don't have the current overview about some €1,000 was on this account, currently. And there are also some, I think 1 or 2K per year was the last time I checked coming in.
Also with donations, what about hardware and or server donations for bandwidth or build bots, or is there anything we as a community can provide to you?
So currently we have some donations from companies. So we have DigitalOcean, which sponsors us some cloud credits, and we use that to run our skit.openwrt or the website, the forum, the wiki, and so on. That's in these droplets from DigitalOcean. I think we get that 2,000 per year, and we have to renew it always. So where we had also the fuck up, but we didn't renew it in time, and when they stopped somehow their program, and we just we need to transfer some money onto this account fast. I think we have to check it again. I think it's running out in October. We're probably again.
Good, okay. I just understood that somebody should take care of that as a yearly task.
Yes, yeah. So we are not really good organized in this kind of things. We had, for example, some CDN provider, but I think they complained that we uploaded too much or used too much bandwidth.
You use bandwidth, but wrong direction.
Yeah, especially with the snapshots, it's often the wrong direction. Probably we upload a lot of snapshot images which nobody downloads.
Would be community voted bounties a way to attract more donations? Stuff like, okay, I'll chip in €50, but please go and make switch names configurable or stuff like that?
I don't know, this needs also some organization on the OpenWrt side. So if you want to organize it outside of the thing, so if you want to give him €50 to fix the switch name things, I'm fine with it. If we do it officially as an OpenWrt thing, it needs also organization from our side. So we have now this legal representation is able to do it, but I don't know if they are really working on this. It's, I think, more for when companies want to do something, so it's not then 50, but more. So for 50, it's for small amounts, it's really hard to manage.
I was more thinking of many people contributing something, and then you get, I don't know, 1,000, 5,000 euros.
So you can, I think this is probably much, so at least from my point of view, it's easier if you can do it outside, so not as an official part of the project, so then I have no problem with it. Yeah, for the project, so currently we have some problems organizing this, such stuff, so we are not really good at it and not really interested. So everyone wants to code.
Okay.
So currently I don't, so if someone wants to organize it outside of the project, that would be fine from my side.
How much does a bookmaster cost? So we can OpenWRT organization can just hire somebody who does all the an accountant.
I don't know. Yeah, that's then also the trust thing. We developers have to trust this person, and normally we trust only developers.
Dang.
So that's also, so we thought about having someone to administer the infrastructure and so on. But yeah, it also needs some organization stuff and trust and yeah, these things.
That's why I also ask for the build boards and or CI stuff, because then if it's only a Docker container, the worst thing that can happen is that the pipeline fails. So
yeah, so if you have some compute resources, so operating a Docker, operating a build board is always interesting. So then we can build the images faster. I think we have something prepared, so Baptiste can probably help you on how to set it up to integrate it into. I think you have you did it for the. Yes, yeah. So he can probably help. So that would be nice. So if you have some compute there, so I think someone said we have here for the university some old hardware. We don't have to pay power for it, so we can run some build boards.
That was before power got expensive. So.
Yeah. I think it was in Germany, so now I don't know where it still is. Was some German university.
No, but for me it's my Pfeifen community has a bunch of servers anyway, and it doesn't really matter if you use them with full CPU all the month or with zero CPU all the month. It costs the same.
Yeah.
So I could just set up and use it something as long as it's not crypto mining or running ZT at home, because that's not allowed. But I think running a build bot is in the acceptable usage policy.
Okay. Yeah, so it's no problem to make it 100% CPU load and or DDR or whatever load.
In the end, if they complain, we change provider.
Yeah.
Until everything is at heads now.
Yeah. So yeah, but it would be helpful. So where we could at least so for this build board stuff. So that needs a lot of compute. So yeah, we had I think some sponsoring from the cloud providers, from Amazon and Microsoft, but running there such a thing is pretty expensive also. So the credits are running out pretty fast.
Yeah, also as I'm building Gluon pretty often, it's the repetitive task. If you want to parallelize it, then you need a huge cache, which is difficult because you then need to sync the cache of the pre-built toolchain between all the nodes, which is a couple of gigabytes, or you build it every time, which takes half an hour depending on the hardware. So yeah, it's not that easy.
Actually, Pfeifen Karlsruhe is already sponsoring.
I think that's the community with the server without power bill.
Yes, that's actually done.
Yes, yeah.
Now I'm just wondering, now that a bunch of new devices are being added, especially on the RAM target again, there's just another Chinese company that just comes around, right? They make the exact same device, just with different LED configurations and stuff. It's mostly just like device tree changes. Like even on the Makefile, you can see that like hundreds of devices have the same additional packages. Now I was wondering if to cut down on the hosting costs, CDN costs, right, to download the images, we could split the compiled DTB image, right? Because if I remember correctly, OpenWRT does this by itself. The SDK it compiles the device tree either by depending on the target from the DTS directory, or it takes it from the mainline Linux. If you could split this, while also on packages that don't have any additional packages for devices, and just when a request is made, just like put everything together and let them download. I wonder if the processing power for this would make up for the CDN costs, hosting costs?
So I think the download costs are not so much. So I think this is currently one a little bit more powerful server at Hetzner, and they have 10 terabyte or 20 terabyte of traffic per month included. The CDN had just the advantage, so when you are outside of Europe, so Paul was in Hawaii, and where the connection to Hetzner was not so good, so he had problems downloading stuff from there. So there will be the CDN with multiple locations worldwide was helpful. So currently the cost is not so. So I think the one problem was the disk speed. So because this rotating disks were too slow for our download server, and I think currently that part works. So that is not such a big problem. It's yeah, more we compute to build these snapshots and so on. So you have some this costs money, so to have the server with the bandwidth, but it's not so expensive, at least. Yeah, what we do now. Okay. They say it's finished now. Okay. Yeah. Thank you for the questions.
And if the schedule is correct, we have a break of -3 minutes now, and then Marek.
Okay. Should I just start or?
Yeah, my talk will be about that. I do some more advertising. I will talk about it.
Okay, then I guess I'll just start. So yeah, thanks for attending. Yeah, I want to give a little talk about Gluon, the Gluon update talk for this year. And the last talk we gave, I think it was in Vienna, so it's been a while. It was at Battlemesh version 10. And yeah, just a little disclaimer, most of the things I'm going to present was work of others, so I usually don't, or I'm not such a big contributor to Gluon, but only for more Batman related stuff in Gluon, so yeah. Yes, you can stream. Perfect. Okay. Can I also switch the slides? Yes, so the agenda will be as follows. So I will start with what is Gluon and a little introduction about it. And then the main topic, what is new in Gluon and the latest releases and what has happened in the last years. And also on the topic on what has happened is this little third point here, which was a little incident we had this year. And that's also basically the reason why I put this exclamation mark in the title. So it's also a recommendation to maybe update if you have still an old Gluon version. Yeah, so what is Gluon? It's a modular firmware framework for mesh networks. So the purpose is to make it easier for you to get your mesh network running so that you don't have to care about the specifics of a specific mesh routing protocol or a VPN protocol, and that the framework will do that job for you. And yeah. It's based on OpenWRT, and The first release was in 2014, March 2014. It's quite popular in Fryphone communities, and also most, or I guess all of the developers or active developers at the moment are somewhat or come from some Fryphone community and are active in them, or were active in the Fryphone community. So a lot of the goals or focus is quite often for what is the need for Fryphone communities. So what are the main features? Like I said, it makes it easier to get your routing protocol running. It currently integrates Batman Advanced, that's what we started with. But also Babel, together with Layer 3 RoamD, is available now. We'll talk a bit more about this later, but it's only IPv6 only at the moment for Babel. And then it also integrates 3 mesh routing VPN protocols now. We started with FastD, which is a user space VPN protocol, which NeoRadar, so one of the founders of Gluon, actually made for this project, because back then, in 2014, things like OpenVPN or Tink were very slow on the small MIPS devices we were using, and FastD was, and as far as I know, still is the fastest user space implementation for a VPN protocol with encryption. So if you have any news for this, something new that is faster in user space, let me know. And we also now added some kernel space ones, which are faster than FastD, which is Tunneldig and WireGuard, and yeah, we'll also talk a bit more about this later. We have ResponD for statistics, which is just a very small daemon, lightweight, which simply sends the data over JSON in JSON format over UDP. Yeah, because we have quite small devices with not much flash, and yeah, so we don't have something fancy or big as MQTT, for instance. And yeah, and we have an auto updater, so that we can seamlessly update the devices from one Gluon version to another one without any manual intervention from the user. And yeah, for more details, especially about the history or the philosophy and design principles, I would refer you to our last talk. There we went into more details about this. And yeah, that's about the main features. And so about what's new since wireless Battlemesh week 10. I will start with some numbers. So the number of nodes currently in use with Gluon are now 44,000. At the last talk it were 35,000, so it increased a bit. And releases, we had 36 releases since 2017. And in total we had 59 releases. Git commits about 2,000 since the last talk, and in total about 5,000. Supported devices in our latest release, so this v22.1 was released just a few weeks ago, and yeah, it has supports now 174 devices. You might wonder why it's less than, if it's OpenWRT based, why does it not support all the devices from OpenWRT? The reason is we usually have a checklist of like 20 items which people have to go through to get it added. So there are things on it like are the WAN and LAN ports configured correctly, is Wi-Fi working with AP mode, with mesh mode, is sys upgrade working fine, and so on. So that we don't have surprises later that, was that a question? Or no, okay, comment, okay. So that we don't have any surprises later that when somebody wants to, when we do a new release and the auto updater kicks in and suddenly the device is gone, that would not be so good. So yeah, do you want to comment now? Or thank you.
The missing devices are also the migration from from the old target for ATHK 9K devices, AR71 to ATH79. So there are not all devices have been migrated. So there's a list of, I think, 20 to 50 devices where as soon as somebody would stand up and test them for the ATH79, then they would be added again.
Mm-hmm. Yeah, we'll also talk a bit later about especially this number. Here you see an older release with a higher number of devices supported, and oops, with the newest release we support less. So I think that also goes in this direction that I will explain a bit more in a few minutes. And yeah, so one of the main tasks, oh, it's a bit cut off, yeah, now it's better, is of course keeping up with what is changing in OpenWRT, and so we have to adapt to any config changes, for instance. And yeah, especially because we want to always keep track that a device from an older OpenWRT will still boot after the update with a newer version. And yeah, so we went through, we updated to Lidi with a 2017.1 version. We updated to 1907 with a Gluon 2020.1 version. And now with the latest release this month, we updated to the OpenWRT 2203. So, and for this last one, the work was quite a lot because we had to check with, or had to take care of that some devices moved from SW config to DSA. So the switches were configured differently. And also the AR711, 71XX target is gone and instead ATH79. So, so before it was based on board files, C files to describe the device, and now it's more descriptive with a DTS file. And because there were so many, so it's so different, it's nearly like a bit of a re-implementation. We also had the policy, okay, if you want device supported again, please retest it. And so we had to retest all the devices which we had supported before. And there was quite a community effort to look around who has this device, who has this device, and for the whole zoo of devices we had. But in the end, we could manage to get quite a lot of devices re-added again, except 4 MB flash or 32 MB RAM devices, because they are, yeah, OpenWRT 2203 on 4 MB flash, it's not working so well anymore. So that's a bit of the downside with the last release, that we had to remove these devices. And we still need to see what happens now, if people are going to throw away their old devices and switch to some newer devices, or yeah. So, but at the moment, at least from the Gluon, the active Gluon contributors, nobody is at the moment has any time or effort to maintain an old stable version on 1907 or something like this. So, yeah. Yeah, the new VPN protocols we've added, you already saw some of them in the previous slides. So TunnelDigger L2TPD was already added in 2017.1, which is in kernel space. And kernel space makes it a lot faster, because when you have the VPN in user space, the packet needs to be copied from the kernel to the user space, and that takes a bit of time. And when it all is in kernel space, usually the throughput you get is a lot faster, and you need less CPU power to use it. However, the downsides with this one were it's unencrypted and unauthenticated, and TunnelDigger so far only supports to use it over IPv4. So that's why another edition was added later, or this year with the latest release. FastD also got some L2TP offloading support, so it can also set up the tunnels. So it uses the same as TunnelDigger, both use the L2TP implementation in the Linux kernel and set it up. Still, the data traffic is unencrypted. However, the setup is, in this case, still authenticated. So the same keys which were used for FastD before can be reused, and before a node connects via the VPN, FastD can check, is this device allowed at the moment to join. And yeah, this is this one. And the last one is WireGuard was added, also in the same version. Same thing, kernel space, so fast, but it's also encrypted and authenticated. So yeah, has more features than this one, but it's also quite fast. And a little bit of the downsides is that the whole header overhead is a bit larger. So to be able to transport, the thing is, WireGuard itself can only transport layer 3 packets. So and Batman Advanced, for instance, is a layer 2 routing protocol, so you cannot directly transfer it over this VPN. So you need something in between, and this is what we currently have, which is VXLAN. which allows to also transport then layer 2 packets over this. And yeah, so if you have if your bottleneck is the CPU, then probably if you compare these two, then if the CPU is your bottleneck, then usually a WireGuard will be the faster one. But if you have your CPU is fast enough, and then it can be that fast L2TP can be faster because you have less, you waste less bytes because of the more headers you add. So yeah. Yeah, that's for the VPN protocols. Then for the mesh protocols, Babel was added with layer 3 ROMD support. So layer 3 ROMD is a daemon which should be usable for any layer 3 routing protocol, and should add support that you can roam with your client device from one access point to another seamlessly. And layer 3 ROMD will take care of notifying the other mesh nodes over Babel that the device is now somewhere else. The thing is, it's still IPv6 only. It was added in version 2018.2. And we still mark it a bit as experimental because you saw we have like 44,000 nodes at the moment running Gluon. However, we are only aware of 50 of these nodes actually using Babel. So there's one Fryphone community at the moment which runs Babel, and yeah, but I think they don't use the latest Gluon version either. So we would really like to have more testers for this, and yeah, would be nice to enhance it. So Batman 5 was also added support for it. This one is also pretty much marked as experimental still, or partial. Yeah, there's maybe a few things you might need to tweak, so if you want to use it. However, there are also some Fryphone communities which are already trying this out. It's like Fryphone Munich and Chemnitz, I think. Yeah. So, and upcoming is actually OS RB2. Yeah, there was somebody from Funkfeuer Graz who posted a pull request quite recently. And yeah, it's currently work in progress, and it looks like it can reuse a lot of the work that was put in to make Babel work. And yeah, it would be nice to have another thing in there. So yeah, one of my favorite topics, because that's what I've also been working on, is to get directed multicast working in Gluon. So this is specific to Batman Advanced. And this feature is basically available since the Gluon 2021.1 release. Yeah. So just for anybody who does not know what multicast is exactly, so usually what we mostly deal with is unicast. So you send one packet from A to B. You have one recipient as the receiver in there. And when you have a layer 2 routing protocol, you might also have heard of this kind of transfer method, which is broadcast. So you send a packet to all other participants on your domain. And yeah, this is kind of sort of essential, or yeah, something which Batman Advanced, for instance, also supported from the start, because it was kind of necessary to have something like this. For layer 2. And the third option is that you have multicast, that you want to send a packet not to one or many or all, but just to a few specific targets. And yeah, for this one, support was added in Batman Advanced to learn about multicast listeners, so that the sending node can already know, okay, how many recipients do I have? Do I have 0 recipients? Do I actually have to send the packet somewhere in the mesh or not? And yeah, for this there was quite a lot of work going on together with a Linux bridge, so that because the way you can learn this is through IGMP and MLD snooping, and the Linux bridge already had some support of this, and Batman Advanced now basically taps into the Linux bridge to get this knowledge and to use it for itself. At the moment in Gluon it's applied for IPv6 link local multicast only. Routable multicast is work in progress, and yeah, as some use cases where it does not quite work yet with multicast routers, for instance. But yeah, that's ongoing. So the current algorithm which is basically used is rather simple. So if there's no listener, the mesh node can avoid sending the packet into the mesh network, so it can just drop it. Or if there are less than 16 recipients, Batman will split it into multiple packets. And so we have here 2 receiving nodes, and it will send 2 packets here, the same ones, and then they will go the separate paths. The advantages of this is typically that you can often use higher data rates, because with broadcasted packets you usually use one of the lowest or lower broadcast rates or multicast rates. And you can also use retries, because unicast packets are usually retried on Wi-Fi as well, so it can make it more reliable, the transfer. If it's more than 16 listeners in Gluon at the moment, it's for essential packets like ICMPv6, then it falls back to the broadcast, which we had before. Or it's for our other packets, it's typically filtered by EB tables then, so we don't let it into the mesh. Because the broadcasting does not scale so well. The bigger the network gets, the more you have of this broadcast then, and less throughput you can get for real data packets. So, and more precise use cases is that one of the biggest overheads we had with layer 2 is ICMPv6 neighbor discovery overhead, so which is like the ARP but for IPv6. And now we can, and there are 2 methods which are used in this thing. One is in IPv6, when a node wants to claim a specific address, it first tries to detect, is anybody else using my IPv6 address already? And usually the address is somehow generated with a MAC address, for instance, or with random bytes. And in that case, usually you have no other listeners in the mesh. So the first mesh node can already say, oh, nobody is having this address, and I can just drop this packet. And the second kind is neighbor solicitation. So this is really to resolve the IPv6 address into a MAC address. And usually only one other node has this IP address, so there's just one listener. And instead of now broadcasting the packet through the whole mesh, we can send it by unicast to this specific node with a specific client. And all this here already reduces the layer 2 overhead quite a lot. And yeah, then we could also relax the firewall rules a bit. So like I said, if it's less than 60 listeners, we can also now allow it. And we are less strict in Gluon now with this. And this allows new applications. Typical applications which people usually say are like, you could use video IPTV things, or like audio conference stuff like this way of group communication. But one pretty simple use case I found, which worked out of the box, which I found quite interesting, and I wanted to show because of that, is SyncThing, for instance. SyncThing is an application which can synchronize folders between different devices. And for that it uses the BitTorrent protocol to sync it. And it's supported by a lot of devices, so you can use it on Linux, on Windows, or on your Android phone and so on. And you can sync your music or whatever between all your devices with this. And it has a local peer discovery feature. So the syncing is done via unicast. However, the peer discovery is used via multicast. And this is a IPv6 link local multicast address. Because here you have a 2, FF12, and the 2 means it's linked local. So this whole application worked out of the box in all the Gluon communities which updated to this version then. And if you have more than 16 people now using SyncThing, of course then it would be filtered again. However, in SyncThing you can also change the multicast address. So if your community gets to this limit, you can, for your own zoo of up to 16 devices, you can specify your own multicast address and then use it again. So, and the big advantage of this is that it's fast. So before it might have to go over some servers, and now it sync thing detects, oh, we are on the same link local. And yeah, if my phone and my Pi with an S and my laptop are somewhere in the same mesh or even on the same access point, then it's pretty fast to sync everything. A lot faster than going over the internet. And I also tried to disable the global, or I disabled the global peer discovery and sync thing, and it still works when I'm connected to the Freifunk network for me. Yeah. So further additions we did to Gluon. Some small packets like Gluon EV tables ARP, limit ARP, so that's some filtering again. Because one of the issues also was that you see more and more devices which scan the whole IP address range they're working on. So I don't know, it's probably some weird Android apps which people install from the Play Store or something, and yeah, they constantly scan the network for all the IP addresses, and this creates a lot of ARP traffic. So we had to find a solution for this, and this is to simply limit the amount of ARP messages a specific client or also a specific node can send into the network. Then we have Gluon EB table source filter. So another issue which sometimes pops up is that people reverse, or they connect the cables wrongly. So they connect their home router not to the WAN port of the Gluon node, but to the LAN port. And suddenly your whole home network would be accessible. But with this you can prevent this a little bit. With this EB source filter you specify your community network IP range, and only this IP range is allowed to enter the mesh network. So if your Fritzbox uses 192.168.178.1, then this will be filtered. And yeah, also for misconfiguring, we also added VXLAN support on the wired machine. So of course, the nodes cannot only mesh over the Wi-Fi, but also you can use cables to mesh to nodes. And this with a VXLAN, you can prevent that, or we also had the case that some people set up two Freifunk nodes from different communities and then put a cable between it. So you had like for instance, a 500 nodes community and another 500 nodes community, and suddenly they were a 1000 node community, and which was not intended like this. And with VXLAN, you can specify, it's pretty much like VLAN, but you have a wider range of IDs you can use. So we usually people then, or each community then has their own VXLAN ID, and they are separated. Even if you connect the cables, it will be disallowed to mesh over this because it's different communities. And all this was also a bit in preparation for this new feature, which was the multi-domain support, which was added in 2018.1. Typically in Gluon you have one configuration file where you specify like, okay, this is the ESSID, the name of my Wi-Fi network, or from our community and so on. And but some communities got quite large and they wanted to split their network into several parts. So for instance, Hamburg then I think split it into 4 parts, like the northern, south, east and west parts. And yeah, this makes it a little easier to maintain these different parts of the network. Then not only the one sort of configuration is on the node, but also for all the different domains, and a person can either select it in the configuration with it, in which suburb they are, and will get into the correct domain. And yeah, so yeah, the intention was to ease splitting the broadcast domain, to ease maintenance of this. And yeah, typical per domain settings like the mesh ID, domain seed, which is used for the VXLAN ID to generate it. So domain seed is just a random number per which community generates for themselves. And yeah, each domain can have their own, or usually has their own prefix for their subnet. And of course you can also select different mesh VPN gateways, for instance, for each domain you specify. And so if you want to have the northern part over a different set of gateways than the southern part, you can specify different gateways in it. Yeah, and on top of that, later came the Gluon scheduled domain switcher in version 2019.1, and this one allows to switch the domain you have configured at a specific time on a node. So yeah, this was implemented to allow migrations which are otherwise incompatible. So what are use cases or examples for this? For instance, you can switch the Wi-Fi configuration from IBSS to 11S mode, which is used for the underlay to mesh between the nodes over Wi-Fi. And we typically use 11S with forwarding disabled because we have Battlemesh Advanced on top, which does the forwarding and meshing. And yeah, you can switch between this, and you can, because otherwise if you were just switching a few nodes, then you might lose the other nodes which did not update yet. So like if you have like a chain of nodes which are all connected via your Wi-Fi mesh, and the first one in the chain updates and the last one did not get the update yet, then suddenly the connection would break because it's a different protocol how the nodes now talk to each other. And so you can now do the update first, you get the firmware on all the devices, but you switch the configuration at a specific point in time, and all the nodes in your chain, for instance, they jump to this new configuration at the same time. And other use cases we had were to switch from the outdated Battlemesh Advanced Compat 14, so this is the version from 2013, and a lot of Fryphone communities still use this old Battlemesh Advanced version because they could not update to the newer Battlemesh version from 2014 because there was an incompatible change between the two Battlemesh versions, and hopefully the last incompatible change between the two. And yeah, but this kind of switching now also allowed us in Gluon to say, okay, we now remove support for IBSS or the old Battlemesh version. So we offered this way for people to migrate, and it seemed like quite a lot of, or most of the communities actually were successful to switch the whole network from one routing protocol version to another one, or to get rid of IBSS. And this means less maintenance work for us. We don't have to support legacy stuff anymore, and because we have an upgrade mechanism now for this. Or you can also switch the Battlemesh 4 or the Battlemesh 5 algorithm if you want to. And another use case is maybe like the Wi-Fi channel. So maybe you now decide you had used channel, let's say you used channel number 7, which is very annoying for all your neighbors because you take a lot of space there, and you want to switch your network to channel 1, then you can also do this with a scheduled domain switcher. Then all nodes will switch to the new channel. Okay, then Wi-Fi encryption, a few things were added, which is maybe not so interesting for, or it's only maybe nice to have for public mesh networks like Fryphone. So for WPA3 support was added. You can use now WPA3 SAE on the private Wi-Fi. So this is a little feature, private Wi-Fi, where you can simply have another AP interface which is bridged to your WAN port. So you have your public Fryphone network, for instance, but also another AP network which is encrypted for your private stuff, for instance, to get access to your home network. And yeah, OWE was added, opportunistic wireless encryption, which is, I don't know if I have to go too much into detail for this, but yeah, this uses some sort of encryption for client devices, even on a public network. But of course, if somebody is going to be man in the middle between the client and the IP, they can still, and if they are an active participant, they can still break the connection in between. It's just for a passive, for somebody who's sniffing the Wi-Fi in a passive way, they cannot read the data traffic here anymore for this connection. Management frame protection was added, so that's a little more difficult to create a denial of service there. SAE on mesh you can also add, which is, yeah, the good thing is it's more standardized than the encryption on IBSS, for instance. And yeah, but of course, if it's SAE, it uses one shared secret, and that's quite unsuitable for public mesh networks, because then you have the password somewhere in your Git, and anybody can look it up. So, all this is not so useful, maybe for public mesh networks. So, but speaking of security, I would come to the next security topic, which is CVE 2022/24884. And it's starting to rain. And my question for the audience would be, does anybody know this guy on the right side here? Okay, 1 minute break because of the rain.
It's running, it's sunny. Okay, the image is perfect.
Okay. Okay. But
yeah, just the power cables. Check them.
So it seems we have a little security problem here at the conference now. Water is trying to invade the Battlemesh. So yeah. So many attackers. It's a denial of service, distributed denial of service. And people are currently doing countermeasures, or implementing countermeasures. But it looks like we're going to be fine. I don't see any smoke or fire yet, so.
Keep calm and keep conferencing.
Okay.
Keep calm and carry on.
Well, the keep calm and carry on fits quite well, because actually the guy on the right side is from a British TV series, and yeah, I still have the question, who knows this TV series? Okay, quite a lot of people, that's nice. So it's from Doctor Who, and Doctor Who, he's a time traveler, and he is traveling through space and time, and maybe you saw this blue police box he's traveling in before somewhere, and he also has a lot of nice gadgets and tools. And one of these tools he has is a psychic paper. So I want to try it out. So who knows the psychic paper? Okay, there's somebody who knows the psychic paper, and what? So Hauke, sorry, I need to take your chair. Yep. So, okay, thanks. So that's how this works. And yeah, my question would be, what did you see on the paper?
Yeah, you are the chairmaster.
Yes, exactly. So I'm the chairmaster. Even though you see it's actually just a blank paper. So that's basically his trick. It's like a psychic trick, and he can show the paper to somebody, and then he automatically gets, the person who reads it reads what the Doctor Who needs to get authority for something. So he can get into places or get people to do something for him. And maybe some people know the thing on the left side, the mascot there? Java, exactly. So
He's the garbage collector.
Garbage collector, yes. And yeah, so all this security issue is a bug we had in ECDSA signature validation for the auto updater, and more specifically in the ECDSA utils package. And the thing is, why the Java mascot is on there is because there was a very, very similar security issue before in Java, and it was published on the 19th of April this year, and it has the CVE number here. So the whole picture and also the name psychic paper came from the people who found the security issue here in Java. And the thing is, yeah, the issue with this is a specific signature with just zeros is accepted. So kind of like a blank paper with just zeros can be shown as a valid signature, and the other side will accept it. And yeah, we had this for the auto updater. You could show a 000 signature, and the auto updater would accept it, which is not nice, not as intended. And yeah, here's also a link for where you can see more technical details about this issue from the Java side. And yeah, and the thing is, 19th of April. I show. Yeah, so we had basically the very same issue in Gluon with the auto updater, the same thing as in Java. And so there was a check missing for the specific 0 values. And I just show some examples to maybe make it more understandable how it looks like. So usually a community here, for instance, from Freifunk Lübeck, for Gluon they make their own site config. And yeah, and there you have things like the Wi-Fi channel your community wants to use, for the Mesh VPN some settings, or for the auto updater. And yeah, here for instance you have the number of signatures which are required, and some keys of people who are allowed to sign the auto update for this community. And so these people can sign, and you need 2 good signatures so that the router will accept the update in this case. And yeah, and for the updates, the auto updater, so we have here like a list of, or just a mirror of the images for the different devices and models and so on with the firmware. And in the same directory we have such a manifest file here at the bottom, for instance, stable.manifest, which the auto updater will download first, and it has and it uses this so that after download it can check, is it the correct checksum, did I get the correct image, and it also has information like when the update should be done, so you have a date in here. And at the very bottom you have the signatures here. So in this case we have 2 signatures here. And like you saw in the sideconf before, you need 2 good signatures to accept it. And with the security bug, you could actually have a manifest file with signatures just like this. So yeah, and actually for the Freifunk Lübeck case, in this case, we thought like, okay, the people who can sign it, yeah, did you test the images? Do they look good, and so on? And then I could just add 2 0 signatures and update to the now fixed version. And yeah, so pretty simple in this case. And also you might notice here it's HTTPS. However, on Gluon for the auto updater in this site here, where is it? The mirrors here, they don't have an S in there. So actually the only thing in Gluon for the auto updater which checks it is the signature, and we don't have an extra SSL certificate which needs to be checked. And yeah, which is pretty bad if you have like 44,000 nodes and you suddenly see, okay, somebody in the middle could basically take over all these nodes. And yeah, these were the examples. The timeline was about like this. So one day after the Java issue was published, so I before showed it was published on the 19th of April, one day later, Matthias Schiffer, from Gluon, noticed, oh, okay, wait, we have the same issue in Gluon. Then he fixes it on the same day, of course. And yeah, then we tested it and did a pre-announcement on the 2nd of May, so a few weeks later, and told told on the Freifunk forum and so on, hey, we are going to have a security update soon in Gluon. We didn't specify any details yet, but just said please get your build machines running and so on, because in 3 days we will release a new version, which has an important security fix. So yeah, 3 days later. And yeah, so that was about the timeline. And then I wanted to show the Gluon census, a little tool we have. Which actually makes it a bit easier to track how many communities did actually update. Because the thing is, the Gluon developers, they make and publish the firmware, or the source code of the firmware, but then the communities themselves can decide, okay, do I want to take this new version or not? Does it look good for us? And these people, they are independent from the Gluon developers, and yeah, they build it themselves and need to sign it themselves, and yeah. And in the Gluon census, I can show it here, a live version. Yeah, you have a lot of information, like how many nodes are currently using Gluon, but also which versions, what is the version distribution, which is the most used version. And here, for instance, we see the fixed version is quite at the top at the moment. So in this case, it happened quite quickly that the people updated. And I can also show it here on the slide. It then looked like this. Within 1 week, quite a lot of nodes jumped. Still, I think there are, from these 44,000 nodes, about 5,000 did not update. So that's again because of the title with the update exclamation mark. Please still update to this new version. And but you can also get or we can also check for the latest release we had this month. And for this one, yeah, people are not so hasty as with a security update. So, but that's fine. People can take time to evaluate the new version and so on. But we can already look in the Gluon census, okay, which community takes it first, which city and so on, or which region. And for instance, Hanover was already updating quite a few nodes, we can see that, or Darmstadt. And yeah, we can keep track of this live in the Gluon census. And another maybe interesting information is we can also see what kind of devices are the most popular in Freifunk with Gluon. So unfortunately still the 4 MB flash TP-Link devices are very much on the top. So we will see how they decide with the update and so on. But maybe you can sometimes already see what are interesting other newer devices which people are starting to use. So the AC Mesh seems to have some adoption, an 11 AC device. And yeah. And we can also go back a bit in history at the moment, so we can check what was used before, some month ago or something. Yeah. Don't know if there's anything else interesting in here. I can just scroll through this. Firmware version in a specific city. So we can also check it per community.
Yes.
Yeah.
A question.
Yes.
Yeah, thanks. That was it. Yeah, in the slide where you show the different steps of the update, is because the community decide when updates, or because there are devices that can't update?
No, because the community themselves, they decide when they want to do the update and when they publish this and so on. Yeah.
So it is the community that decide the day that will happen to inform people.
Yeah. The Gluon developers themselves, they cannot update all these 44,000 nodes.
Can I have another question on this?
As many questions as
do you have, is it sad when your router has not enough flash memory to be updated to the next version? And what do you do in this case, or if this case happen?
When it does not have enough flash, yeah, that's the issue which we kind of have now. So far we always told the communities, hey, you have to at least promote newer devices with more flash, or you have to prepare to switch them. Also some communities have experimented with desoldering the flash chip and soldering a new one in. And they did it for, I think, probably hundreds of devices already. But it's very tedious work, of course, to resolder all of them. And then for this modification, at the moment, you also cannot get it upstream into OpenWRT. So you would have to, or the communities would at the moment have to maintain it downstream. And yeah, it's a bit of an unsolved issue now, what to do with all the devices. It would be a shame if we produce so much waste now with so many devices. But yeah, if anybody would have a solution to reduce the amount of flash we need, that would be great. But at the moment in Gluon, we already have no TLS in there, no WORth SSL, for instance, and yeah, it's getting a bit difficult. Also because the kernel version is growing bigger and bigger, and on some devices the kernel does not fit into the designated kernel partition anymore, and yeah, so could be that maybe some communities decide to maintain an older Gluon OpenWRT for a while. I don't know, but that cannot be a full solution for the future, I guess. Yeah. Okay. Any more questions for this part so far? A bit out of time. Okay. Yeah. I think it's also pretty much the end already. So maybe that. So. I think with the rain I'm on time, maybe, if you reduce the 2 minutes rain. So yeah, here you can find the project, the code, or on Metrics you can also reach us, or on IRC, or on a mailing list. And yeah, any questions, and thanks for listening.
Just the auto update. What does it mean? That when the community decides, all the router updates automatically, or that? What does mean the auto update? So the community decides that it has to be updated. Okay, they publish the update, and then the routers automatically apply it at the specific time. Or how does it work? Because if the router automatically applies, I would expect all the routers to update at the same time, no?
Yeah, no, in this case, not, because there's still some distinction between the communities and the developers. So it's I mean
the routers of a community. When the community, the people managing this community decided that all the routers can be updated, they publish the update, and the auto updater updates all at the same time, right?
Actually, it stretches it a bit. So if it's a bit more of the specifics. So you have in the manifest file you have a specific date which tells the routers when they can start to update, and the priority says that the update should be spread over 7 days in this case. So priority 7 days. So after 7 days all the devices will have updated, but not all at the same time. If you set the priority to 0, then they will all immediately update when they see there's a new version available. So that's
very nice. Thanks.
That's a little safety feature. So if you see like, okay, on day 1, we lost 10 nodes. On day 2, we lost another 20 nodes. Then people can stop publishing the update and can check what's going on. Yeah.
Very nice. Thanks.
Yes. You're welcome.
For us in Chemnitz, the ECDSA issue even was a lucky thing happening, because the server broke down that we did our signing on, and we did not have a backup of our signing key. So we, for roughly 1 to 2 years, were unable to publish any new firmware, and then ECDSA issue came around, and we just thought, oh, that's actually good for us.
Yeah. Yeah, I guess in this case it's not a bug but a feature.
Yeah. Bug and feature is sometimes different to it.
Yeah.
So, and this was the one comment, and for the Gluon config auto updater, keep in mind there are OpenWRT versions which have a buggy NTP implementation. If the first NTP server fails, it does not try the second one. So if your router then has the wrong date and is in the year, I don't know, 2000 or 2010, it will not change at the same time as every other router. Keep that in mind. Because we had it in Chemnitz that we had an internal NTP server first and then public servers. But then this server broke down sometime, and then we just thought, okay, there's the second one. Yeah, did not happen. Luckily, we did not use the config auto updating feature, but I recognized it at some point because I wondered why, even after the Gluon priority for the rollout of the update, why so many routers did not yet update. And if they have the wrong time and think they are still in the year 2015, then the date in this manifest file is not yet reached. So it thinks, well, okay, I should not yet update, and keeps running old versions. So as a reminder, check on your, if you have SSH access to some routers, check for the date. There might be issues. Next question, comment, remark, insult.
Okay, if there are no more questions, then thanks for listening again.
You are online.
Some people predicted when I start, the power will be turned off by higher forces. We'll see.
Put the microphone.
To your left, there's the socket to your left.
To my left, there, this one?
Yeah, yeah.
Yes?
Strong. Yeah. Yeah.
F12? No.
The application find it perfectly. Failed successfully.
How far down should I attach this?
I'm asking to everyone. There will be one moment in the future that Linux will support all the graphic cards without these issues.
Here we go. Right there. Thank you. Thank you. Does that work? Now. Ah! There we go. I just had to put it on the right screen. Okay, shall I start or?
Yeah,
Good. Any similarities you may find to the title are purely coincidental. My lawyer told me to say that before I start. So, due to popular demand, I will be talking about chips and computer chips in particular, and where they come from and what all the news that we hear about mean. And to get more attention, it's dubbed Chip Wars. And we were talking about onshoring. I will explain why this subtitle. First, a little bit about myself for those who do not know me. I know some of you do, but not everyone. I'm from Berlin, have a software background. I was involved in Freifunk and free wireless networks. And back in the day, same as today, there was always the question, what is the new hardware that we can put our OpenWRT on to connect to our neighbors and make the network grow? And somehow, one late evening, we had this brilliant idea, somebody should go to Taiwan, that's where the hardware is made, and should figure this out. Where this is coming from. Somehow I was the sober person and I was volunteered by everyone, I should go to Taiwan. So I went, I attended a couple of conferences, I met a bunch of people, and
long story short, I ended up moving there, and then I lived there, and I worked for hardware manufacturers. In the end, I lived there for 10 years, first in Taiwan and then in Hong Kong. And I'm working in hardware manufacturing, that is access points. In the beginning, I did smartphones, then access points, switches, everything that comes out of a factory, I was involved in. I try to get out. This is why this is me, in case you haven't guessed. I try to get out, but once you're sucked into this world, it doesn't let you go. And the reason is here in Europe and also in the US, there's very little knowledge about how hardware is made. So every time I show up, oh, you know how hardware is made, then everybody comes and asks questions. And in the same as in Asia, software knowledge is very, very rare to come by. And then, oh, you're the software guy, and you know how hardware works. Explain this to me. So I'm in between these worlds, and I often find myself explaining left and right what the other side wants and how they work. For a living, I do large hardware production in Taiwan. Large means like 10,000 of devices in a production run. But in my free time, I also help with open hardware projects. Most recently, I was involved in the LibreRouter project in the early stages because I was living there and they needed the contacts, and then I helped them to get started. And I also am in touch with a German project doing drones. They want to produce their first drones for rescue operations. So this is what I do in my free time. So, what do we cover today? First, we do the 101. I know you will have undoubtedly heard some of the words that I will be talking about, but I want to give you some more background about these terms and words that are thrown around when it comes to computer chips, because they are not as well understood here in this part of the world. Don't worry, it won't be too boring. I've prepared a couple of entertaining injections there. Then we will talk about what happened in 2022 alone. I picked some highlights that will couple feedback to what we've learned in the first section. Then we talk a little bit about the future, where things are headed. And I left plenty of space, unless I talk too much. You can interrupt me if I talk too much, for discussion. So you can then throw in questions, and I can explain more in detail whatever may interest you. So let's get started. So 1.15 trillion is the number of semiconductors produced in 2021 alone. So just to give you a scale of what we're talking about, this is the number of computer chips produced in a single year, 2021. Of course, it's growing, roughly 10 to 15% a year. So in case you have problems with large numbers, I put the zeros down there so you know what trillion means. If you want to do a rough back on the napkin calculation, it means 148 chips per person on this planet were produced in 2021 alone. So just to give you a scale of what this production that we're going to talk about means. Of course, not everybody got 148 chips. I don't know if you got 148, but there are a couple of people in Africa and so on that don't get that many chips. So it's not evenly distributed. It's just to give you an idea, what we're talking about. Now, I want to start by talking a little bit about where are the computer chips produced today. This is from 2021, the numbers from 2021. By the way, if anybody wants to look this up, you don't need to take notes, anything. I will upload the slides. And at the last slide, I have a whole list of references and sources. So you can read more. If you're interested, there's a whole bunch you can read about all this stuff. So don't worry. So about 10% of the production of the chips is in Europe, 20% in the USA, and 70% in Asia. And this is why most people think that modern technology is coming from Asia. And we will talk about this. We will unpeel the onion, and we will also deal with some of the common myths that are propagated in the popular press and some bloggers. Okay, so the key takeaway is Europe still has some production, not much. USA has still a decent chunk of production, and the rest of the production concentrates in a few areas, mainly Taiwan, we'll get to that, then South Korea, a little bit in China, and even less in Japan. That's also very different. Like in the 90s, Japan was very big in chip manufacturing, and it's basically non-existent today. Now, the next vocabulary we have to learn, if we want to dive into this world, is the difference between pure play and IDM. So let's start with IDM because it's easier. IDM are the companies that produce chips themselves under their own brand. So think of Intel. If you have a laptop, there's certainly Intel inside, Wi-Fi and CPUs and so on. And they have their own factories. And they produce their chips in their own factories. That's what IDM means. As we can see, there are only 3 IDM players left. There's Intel, Samsung, and Texas Instruments. Texas Instruments is actually negligible. They only make special chips, so it's basically Intel and Samsung. Everybody else that makes chips goes to a pure play company. These are chips that are not known brands. These are companies that only have factories. They don't have any of their own chips. They make chips for other people. So if you have an NVIDIA chip or you have an AMD chip or any of that sort, it's produced by those pure play companies. Okay, so the main difference is either I make chips for other people or I make my own chips. Of course, this comparison wouldn't be fair if we didn't have an exception. So you see Samsung is on both sides. So Samsung makes their own chips and they make chips for other people. To be fair, they mostly make chips for Korean DRAM companies like Sky Hynix. But nonetheless, they're on both sides. But mostly it's separated in 2 parts. What's also interesting is I put a little flags there. So Intel, I think we know, is from the US, and Samsung is from South Korea, and Texas Instruments, of course, US. TSMC, Taiwan Semiconductor Company, makes 54% of all chips in the world. So of this 1.15 trillion, they make 54% alone. And then you have Samsung in South Korea that make a bunch of chips. Then you have another Taiwanese company called UMC, which only has a 7% market share. You get to Global Foundries, in case you're wondering where that's coming from. That is the former AMD factories. They had to sell them when they needed cash, and now they're called Global Foundries, and American companies. And then you get to SMIC, the only chip manufacturer in China, in mainland China. Okay, so far so good. We further unpeel the onion. So, whenever you get to talk about chips, you have to talk about nanometers. I hate it, but unfortunately we have to deal with this. Everybody has, in this business, size matters, but everybody wants to be the smallest, not the biggest. It's very different. So to give you an idea what nanometers is, I put a little scale on there to tell you what these companies are talking about. So the human hair is in a micrometer range, and DNA is 2 nanometer in size. So when companies talk about, oh, we make nanometer chips, they mean we're making chips that have transistors on them that are a certain amount of nanometers apart. And the smaller the number, the more transistors you can put, and the more powerful your chip is. The more cost effective it is, and the more energy you can save. So making it smaller gives you a lot of benefits. So everybody wants to be the smallest. Unfortunately, if you look at the scale, that's why it shows it, you can see that the atom, the size of the atom, begins at 1 nanometer. So if anybody tells you, I can do 2 nanometer, then you have to ask, really? You can do 2 atoms apart, you can put transistors? Are you sure about that? Of course not. So like 10 or 20 years ago, that was correct. So the nanometer really meant the distance between transistors. But recently, in the last 10, 15 years, when companies come out with nanometers, it doesn't really mean it's the distance between the transistors, because nobody can make it that small. We cannot bend physics. But everybody's trained to go smaller, so they're announcing, I do 6, I do 7, I do 3. And then everybody feels good. Another thing that's important to point out when these size comparisons happen, when Intel does 10 nanometer and TSMC does 7 nanometer, it's not necessarily different. They just have a different name. So 10 nanometer Intel is actually the same as TSMC 7 nanometer. It's just a marketing term. I'm emphasizing this a bit because I will be talking about nanometer, because most of the statistics and most of the graphics talk about nanometer. So I just feel this as a warning. Even though I will be talking about nanometer, keep in mind it's a little bit of a marketing gimmick. It's not really nanometer. It's small, but it's not that small. Another thing I want to talk about real quickly is when we talk about nanometer and chips, of course, most people think about computer chips like CPUs, and we talk about 7 nanometer and 10 nanometer and 3 nanometer. But there are a whole bunch of other chips that fall into other categories of sizes that are still produced by one of these companies I just listed. So just to give you like a rough overview, if we go talk about power management ICs just here in the middle, that would be in the range of 40 to 28 nanometer. These statistics are coming from TSMC, so they're a little bit inflated. Don't take this as face value, but it gives you a rough number. So you can see 40 to 28 nanometers, that's where power regulators that you need in batteries, that you need in your chargers, you have little chips that regulate the power. Those chips that I list here are typically a little larger. So you see they're not on the super small 10, 7, 3, 5 nanometer scale. They're a little bit larger because it's cheaper to make, they're longer cycles, but they still need to be produced. So power management, 40 to 28, they're currently transitioning to 28. That's why I put a little larger sign here. So they're transitioning to 28. Wi-Fi, for example, on laptops and smartphones can be extremely small, down to 6 nanometer, but it can also be larger if there's more space. So just to give you an idea, which type of applications need different sizes of nanometers or different types of compaction. So why does this matter? Because here we're looking at the pure play companies, so those that make all the chips that are out there. We can see we have a nice statistic. If you're interested, there the source is not made by me. It's an official statistic from 2020, not 2021. And that shows the distribution of the production capacity of certain nanometer-sized chips by company. You just have to remember the big blue blob, that's Taiwan. So this is TSMC. Then you have a little bit of Samsung in South Korea. You again have Global Foundries in the US, UMC, again Taiwan. And China is basically the small pig bits and pieces. We can already see the smaller the nanometers, the less there are manufacturers. So when I showed you at the beginning the global market share of certain vendors, that meant all the nanometers. But if we look at high-end, like 5 to 10 nanometer, it's highly concentrated in Taiwan. So we're almost done with our intro. We have to cover 2 more things. One is when computer chips are made, they're so complex. It's not that they're sitting an engineer in the lab somewhere in the basement and soldering something. No. This is done with software. So it's like an Airbus or something of that complexity. There's huge software involved that is used to design and test chips even before they are brought to production. And here, these software are called EDA, or Electronic Design Automation. This is the type of software. So don't think about it as a software you can download on your laptop or something. This is like cloud-based and big stuff. And basically, often if you want to use that service, you book a service if you want to use the software. You don't just download the software. And you can see, so here's the market share of the 3 big players that are available right now for high-end chip designs. You can see all of those software is coming from the US, all of it. In the remaining 31%, you have a couple of other players, European companies, some smaller US companies, and 1 Japanese company. And one minor note, even though it says Siemens here, because Siemens acquired the company, it's still a US company. So the software needed to design chips is in firm control by American companies. So, the last topic for our intro is lithosphere, or the lithosphere as it's called. And that's maybe a bit positive for us here as Europeans, because we talk a lot about Taiwan, about US. What are we Europeans good for? You know, do we only consume this stuff, or are we involved somewhere? And the good news is, yes, we are involved in this whole process. So we've covered where the production is. We've covered the software that's needed to design the chips. But how do you make these chips? You need machines to make these chips. And these machines are coming from Europe. So with the current trend, how it's going, we're talking about 3 different levels of sophistication of making these chips, or making the machines that make these chips. So we have DUV, EUV, and high-NA. So DUV, as it says, is the old stuff. Just think of it as legacy. Here we have like the 90 to 28 nanometer-ish type of production. Some try to push it and try to go to 20 or 14, but it doesn't really work well. Then we have the EUV, that's the currently hot stuff. First factories coming online using EUV this year by TSMC, of course. This is for really high-end chips down to the 5 nanometer range. And the high-NA is the upcoming cool stuff. Think about your Wi-Fi 7 is coming high-NA in 2 years' time. So what's interesting here is the vendors. So we're talking about machines that are produced somewhere and then shipped to where the chips are produced. These machines are built, the DUV machines are built by 3 different companies. So we have ASML, Canon, and Nikon. And if you note, for EUV, we have 1 company, ASML. And for high-NA, we have 1 company, ASML. Has anybody, except for Dutch, heard of ASML? Yeah? Okay, a few. Okay. Any idea how big ASML is? In terms of, I don't know, employees, revenue? They do only produce, well, they've reached 100 now, correct? They produce 100 machines this year or last year, yeah? Okay. Now the Dutch will be very happy. Let's talk about ASML. He's already smiling. Let's talk about ASML. It's a gigantic company. Market cap roughly 200, 225, 250 billion euros. They work with companies all over the world. They say on their own website they have 4,700 suppliers to make 1 machine. It's a gigantic company. It's a European, like Dutch. It was founded by Philips, of all companies. But it's spread out. Basically, they have suppliers all over Europe. Key suppliers are in Germany, also in France. I picked a few. Carl Zeiss is making the mirrors. There's some companies in France, other companies in the Netherlands, and of course in the US. They make the machines that make the chips. Without ASML, no machines, no chips. It's very simple. They're so big, they're starting to buy companies. There are a lot of companies that only produce for ASML. And one of them was Berliner Glas, which is of course an important mention because that's where I'm coming from. It's from Berlin, and then they acquired the company to help with their optic installation. So I want to dive a little bit into what this means, because later we will talk about ASML and why it's so critical. And here we get into the geeky territory, and I think I have the right territory for this, so the right audience to talk about geeky stuff. So these machines are really big. You need basically 4 jumbo jets, and they charter 4 jumbo jets to pack it up and fly it to where it will be, and then it will take several weeks or months to install it to make the chips where they go. They don't come cheap. So the official price is 200 million a piece or 300 million for the next generation. Of course, if you buy more, you get a little bit of discount. From the geeky perspective, this is really if you're into science fiction, this is science fiction. What they're building there is a machine in total vacuum. When they make the chips, it's like a round piece of, it's called a wafer. It's made of silicon, and they put that in there, and then they have fine lasers that cut the transistors into the silicon using light. And this is this ultraviolet light that they're using to cut the chips out of the wafer. And it's so fine light and so sensitive that everything has to happen in vacuum. If there were air in there, the chips would break. They would not function afterwards. So it's total vacuum. It's really cool stuff. They have mirrors to reflect and filter the light, and the mirrors have to be so straight, any little error and the chips will break, will not work. And I heard about a statistic. They're putting mirrors in there that are so straight that if they will make the mirrors so big as the Netherlands, at its highest point it would be 1 millimeter in height. Otherwise, yeah, it would not work. So this is really science fiction. If you're interested in complicated science fiction stuff, physics, this is the edge, this is the frontier of what we can do. Look into this cool stuff they do there. Okay, quick summary for the 101. This is was our quick rundown. So semiconductor or IC industry is dispersed in a sense it involves many different countries, many different players to make a chip work. You need to have the software, you need to have the machines, you need to produce this somewhere, and so on and so forth. The concentration is very high. Like in the machine production, like the building the machines for the chips, to make the chips, we only have one company left, that's ASML. For chip production itself, we have TSMC and mainly Intel, and Samsung also around the corner. But other than that, it's just in a few hands. But most of this stuff is coming from Western technologies. So you have Americans that are involved in research, you have Americans that do software, you have the Europeans that do a lot of research on the physics end to build the chips and build the machines, and the production is in Asia. Okay, that's the key summary of where we are right now. Do we have any questions so far? Or shall I move forward? Yeah?
How China acquired
Oh yeah, Mark, use the microphone.
how China can make something due to the embargo of the United States?
We come to that. So that's what I'm covering in the next section. That's a very good question. Any other question about this stuff, or shall I move forward? Yeah, there's a question. Microphone, microphone.
Why Taiwan? So why are they produced there?
Yeah, good question. It's as often it's historic. I give you the short rundown. They were just in the right place at the right time. I've heard different stories, but during the Vietnam War, when the US Army was busy fighting the Viet Cong in Vietnam, they needed a base, and Taiwan was conveniently located between the US and not too far from Vietnam, and so a lot of contacts were established between Taiwan and US, and that's where it started, so to speak. And this is very run. This would be a long discussion. That's also not covered by this talk. If you want, we can discuss it later. But that's the short gist of it. Yeah.
Last question, and it's not a political question. Just
no political questions. Okay.
No. How can a state like Russia, in the current condition, acquire chips if everything is run by West?
Yes, we come to that as well.
Okay, perfect.
That's what everybody's asking. So we have to clarify all of these things because they will be very important as we move forward. So let's talk about 2022. We will cover Russia. We'll cover those topics. So first we talk about Huawei a little bit. I think everybody is familiar. Smartphone maker Huawei. It's not exactly this year, but it shows a pattern that we can recycle later. A little bit of foreshadowing here. So for those who are not following this Huawei case, so in 2018, 2019, the US started to be aggressive towards Huawei, and we're not talking about the political aspects, we only focus on the technical aspect here. The why and is that necessary and so on, we can discuss later off camera, of course. So the first step that the US will always, or the US Department of Commerce will always do, is they put a company they don't like on the so-called entity list. What that means, for those who are not familiar with the entity list, that means US companies are no longer allowed to sell goods to this entity that's on the entity list. They can still buy, that's a common misconception, they can still buy, but they cannot sell to this company. So in May 2019, the US government basically decided, okay, we don't sell to Huawei anymore. That means we don't sell software anymore, we don't do any business with Huawei in terms of chips, software, whatever. And typically how this works is they give a grace period so that everybody can adjust. Of course, they don't care about Huawei to adjust, they care about their own companies to adjust, so that American companies can adjust. Yeah, we don't care about Huawei. So that expired in August 2019. And it was already obvious that while this is bad for Huawei, because at that point they couldn't use Android anymore, and they couldn't buy chips directly from US companies, but they could still buy chips from other companies. So the US government came up with another way to make this enforcement stronger. And that is, they instituted a ban on everybody and everything that was made with US equipment, US intellectual property, which means software, blueprints, everything. And that's interesting because, as we mentioned before, the software to make chips is American. So any chip that was built with software that was American can no longer be produced for Huawei. And Huawei had tried already for many years to build their own chips, a bit similar to the Apple chips that came out a few years ago. And they called this chip Kirin. It was built on ARM designs. It was made with American software, but it was still their own chip design. And they went to Taiwan, to TSMC, and said, hey, produce me this. And TSMC produced this until May 2020. So because of this US directive, TSMC and Samsung canceled all ongoing contracts with Huawei for their own chip designs. So effectively, the US has found a way to prevent China from, not China, but the Chinese company Huawei from producing any chips whatsoever. And this is how they do this. And we will come back to that because this will apply to other topics as well. Just to show you the effect, because this started in 2019, 2020, we can already see what people have predicted. What would that do to Huawei? I found a graph that gives you kind of an indication where that's going for Huawei. This is 2021, so we're expecting this trend to continue. So basically Huawei is out of the smartphone business. They cannot build any phones, and probably they will have difficulties to produce other hardware as well, like the telecom infrastructure. But depends a little bit how hard the Americans going after Huawei. So this is a warm-up basically to what came after that. Now we talk about Russia. So a lot was talked about sanctions on Russian oil, on Russian gas, on parts from Europe and companies pulling out and no more McDonald's in Russia and how sad all the Russians would be. I'm sure they're sad. But it was an event that I felt was not much talked about, which is the US took this same approach that they took with Huawei and applied it to Russia as a country. So they said, no more chips for Russia and no more production for Russian chips. Any Russian chips for any company in Russia. And in the if you read like the technical press on this, and I tend to agree, this kind of is like a death sentence. We have seen countries, or we have countries like North Korea and maybe Cuba that today live without chips, but they never had chips. Now imagine our society or something like our society, and from now on we cannot make any chips anymore. Somebody has a question from far afield. So this is really something to think about and to keep an eye on the next couple of years. It means that no more chip production, no more chip import into Russia for anything. And to bring that home, I have a little overview about what today all uses computer chips that are affected. So not only our computers and smartphones, and of course our Wi-Fi access points that we care about, but
it would be easier to say what is not using chips.
What is not used to chips? Yeah.
Exactly.
But it's just, I'm trying to imagine you have a life and you remove all these things from your life. Because even though you can extend life and maybe your toaster or your fridge isn't dying today, but in a few years, maybe you want to move out from your parents' home and you need a fridge. Or your toaster dies or something and you can't buy it because it has a computer chip inside and you can't get computer chips. And to drive this really home, I have another example here talking about cars. So this gives you an overview about where computer chips in cars are used today. Not only in the entertainment system and in the AI that helps you driving around, but airbags, seat control, power management, battery management, fuel management, all powered by chips. So, and we're starting to see the first impact of this in Russia. I've seen the first numbers that car production has imploded because they can't get the chips, they can't get the parts. So car production in Russia has imploded down, I don't know, 70%, 80%, I don't know what the real numbers are. It's not my field of expertise. And what are they doing now? Well, they're trying to revive the old cars from the 60s, 70s that didn't have airbags, that didn't have automated brake support, it didn't have all of this, so they can still make cars that go. And they can sell, basically, and can drive around. So we're still at the beginning of this. It will take a couple of years to see the effect. But Russia is basically converting back to a society where computer chips don't exist. And it goes to the point where it comes back to the question we had earlier. So there's a credit card manufacturer using the Russian credit card system, Mir. They cannot make the chips anymore for new credit cards. I mean, do the math. I mean, no credit card anymore. Goodbye. This, depending on how this plays out, how the things evolve in Russia, it will take a couple of years for this to take full effect. But this will be an experiment on a scale we haven't seen before. It's like a society going back to life without computer chips. Okay, so where am I doing on time? I don't see the time anymore. Am I talking? No? Good? Okay. So let's talk about China. The US has already imposed a ban a couple of years ago, or has pushed ASML, has pushed the Europeans to not sell EUV, which is the cool hot stuff right now, to China. So that they cannot build factories that build chips 10 nanometers and smaller. Now the US starts to push for even the old stuff, DUV, also not to sell to China. The Chinese can still buy chips from Taiwan and from other companies, but they cannot produce them themselves without having the ASML-made machines for the factories. Also, the US just recently imposed a ban on the software that we talked about. So the software to make the chips cannot be exported, cannot be used in China anymore. Just very few weeks ago. And then we got one really recently. I had to update my slides. They introduced a ban on high-end chips selling to China. These are the so-called AI chips, graphic card chips. Now, I don't think this is about Bitcoin mining in China. This is more about data centers because you use these GPUs, these high-end GPUs. It's not even for laptops like A100 and H100 in data centers for image processing, image analysis, video analysis,
Creating this floating point.
Yeah, but it's more complex than that, but it's like more really for if you want to build like automated surveillance system, you want to detect like who's walking there, you want to automatically identify, and you have an AI that analyzes that. You will use these kind of GPUs. They're optimized for that kind of operation, and those cannot be sold to any Chinese company anymore. Just recently, since September 1st. Of course, this is a long game as well. This is not about a short game. This will have an immediate impact because they can't build new data centers with those chips. They can still buy the older chips. It's not that they can't do it. They can buy older chips that are less efficient, so they have to put more resources into that. They have to spend more energy doing that. But this is also, there's a long-term thinking behind this because these chip designs are always done close to the destination. So if you are a chip manufacturer like NVIDIA, you want to sell into a certain area, you want to produce these chips, they're so complicated, you do this where this is produced and where your customer is. And this is also a way to push these companies to move production back to the US and move their design centers and their development efforts back to the US. We'll see how that plays out, but I expect, based on previous patterns, they will probably in 6 months you will see an increase again. This is the first shot basically on these type of chips, and they will increase. Yeah.
Microphone.
Yeah. Yes. Microphone.
Yeah.
We are under microphone.
The ban include also the product that contains these chips, or also
Yes.
for the business
Yes.
to business. Also
Yes.
the product.
Yeah.
Oh, okay.
Yeah. So that's the highlight of just what happened this 8-9 months. This is a long saga. It goes on. It will continue in the future, and it will have many repercussions moving forward. But you can see that the US is very protective of like their computer chip industry, and they don't want to help the Chinese to catch up. So we'll talk a little bit about Outlook, and then we can go into general discussion mode. And if you have any questions, we can dive into this. So why did I adopt this onshoring? So onshoring is in business speak, is the opposite of offshoring. If you are a company that produces something, let's say in Europe, and you want to make it cheaper, you produce it somewhere else outside, like in a country where labor is cheaper, that's offshoring. When you bring it back home, that's called onshoring. So both the EU and the US, due to the COVID pandemic, have discovered it would be really nice if more chips were produced here, because then we would not depend on these Asian manufacturers. So onshoring is the word of the year for these type of decision makers. So for example, the EU announced the European Chips Act. I don't know if anybody has heard about that. Yeah, okay. So they allocated another 15 billion to help more chip manufacturing, new chip designs, improved chips, etc. in Europe. They had already 30 billion last year, so they're basically increasing that amount. They had a bunch of other projects. Horizon, I don't know if you've heard about this. I talked to some chip engineers in Barcelona that are working on under the Horizon program on high-end chips. So the European Union is investing, let's say 100 billion, give or take, right now to develop new chip production means and new chip designs and have the production here in Europe. They have set themselves an ambitious target. They want to do 20% global chip production in Europe by 2030. I think that's really ambitious, because that means they need to grow faster than the market. They need to have more production here than elsewhere. We'll see if that plays out. And then the US has done something similar. They also have a CHIPS Act, very similar goal. They want more chip production in the US. I read that Biden signed this into law. It was 52 billion, and one day after he signed this into law, I think the House I'm not so familiar with American politics, but suddenly it was 280 billion. I have no idea how this works, but anyway, lots and lots of cash is thrown onto chip production here in Europe and in the US. A bunch of companies also joining in. So on the forefront is Intel. They have very, very deep pockets. And now we talk a little bit also what this costs and what the time span is of those kind of things. So they have a production facility in Ireland already where they produce chips. They're extending that. They throw in another 12 billion. We will have a new factory in Germany going online, roughly 2025, 2027. We'll go online in stages. Another 17 billion. If you feel like it's a lot of cash, yes, it's very cash intensive and it takes many years. They're searching for a site in Italy where they want to also build a factory. It will be not so high end, that's why it's cheaper, 5 billion. And they open an R&D center in France and Poland. Yeah, question? Microphone. Yeah.
In Italy, I think they built a packaging center, so not.
They also. I did not list that.
I think really it's not the real fab. That's not enough money for a fab.
It is a 300 nanometer fab.
Okay.
Yeah, that's why I said it's old stuff. But you're right. Usually they're much more expensive. They have bought a company there, and they're probably extending. They've bought an Italian company. Yeah, I don't want to bore everyone with those details here. But you can see also if you want to increase chip production or you want to build a factory, we're talking about like 5 years or longer to build such a factory. That has many, many reasons. A factory is a complicated thing to build. You need to get a slot with ASML to get your machines. And ASML only builds 100 of those a year, or they're trying to boost production. So it's not easy. It takes a lot of time. And it's a lot of money. Nobody decides this on the whim and say, oh yeah, we just built a factory here, blah, blah, blah. No, it's a lot of cash. It needs infrastructure. You cannot build a factory in the desert. You need a lot of supporting infrastructure. You need the right workers and supply chain, etc. They're also building in Arizona. You will see the name coming up quite often. Arizona is a popular destination because there are already a lot of chip manufacturing in Arizona, 20 billion, another factory, Ohio, another 20 billion, and New Mexico, it's a Q&A packaging thing, 3.5 billion. All newly announced this year or last year to boost production, and they will get some funds from the EU and from local governments, so they don't have to pay all this by themselves. And very interesting is Intel wants to go into pure play, which means they're thinking about and working towards making chips for other companies, which is very interesting because right now TSMC is so big, there's only one company doing that basically. Now a couple more numbers. Of course, TSMC, it's really a novum, is building its first high-end factory outside of Taiwan in Arizona. So the US government has put a lot of pressure on TSMC to build a factory in the US. Samsung was also pressured in building in the US. The EU Commission has also tried to convince TSMC and Samsung to build in the EU. They were not successful. And even Texas Instruments is building a new factory. Until last year, they planned to go fabless. So they wanted to get rid of the last factory they have. They did a 180. They're now building a new factory from scratch for their stuff. They don't want to produce in Asia as much. So just to show you how the flow is going, where the money is thrown at, we will have to see how this plays out and what the changes in the long term. It will take a couple of years until we see the effects of this. Now, why is all of this happening? And here we come into a slight political territory, but we will not go into deep. We start with a thought experiment. So I invite you to follow me on a thought experiment. So, picture yourself, you represent a nation state, an important nation state, or at least you believe so, you are important. You import a lot of chips. Every year, you may even import 432 billion worth of chips in 1 year alone. That's money flows out of your country to a neighboring country, perhaps, and it's the biggest chunk of money you spend on anything for import. even oil, you only spend 250 billion. So you've spent twice as much on chips as on oil. Just to give you an idea how important chips are today. Now, you would like to produce your own chips? You have thrown a lot of cash onto this, let's say hundreds of billions over 20 years. And honestly, it didn't go anywhere. It was a disaster. And you had a nice big company, a known brand that was known in the world. It was selling a lot of phones, and it gets obliterated by some other country, literally in a drive-by shooting, because the other country, they don't even sweat. They just kill them, and there's no repercussion, nothing. You just watch how your company dissolves. What do you do at this point? Here's a thought experiment. What do you do? You feel dependent on the external, the outside world, while you believe you're so important. How can that be? Well, I would say you open a map of the world and you look around and try to figure out how things are. So I do this for you. For those who are not familiar with this part of the world, here's the world map. This is where the large part of the map shows. So here we have Southeast Asia. Highlighted, the big chunk is China. The small island there, that's Taiwan. That's where almost all our chips come from. And that's South Korea, where the other half of the chips are coming from. So, you see all this chip production right in front of your doorstep. What do you do? Yes? Microphone.
Did you give us a clear review that without the software and the hardware from Europe and USA, even if they acquire Taiwan or South Korea, they can do nothing. It will be a useless fab.
Well, the fabs there are functioning.
Yeah, but there is a stop function without all the support, because in the moment they stop the software, for example, and they stop shipping and divert all the shipping to the Europe and USA, is what TSMC declared. If they invade us, all the contract and make us work will be invalid, and basically...
That's true, but there's another side to this coin, which is, if all our chips that we are consuming are coming from there, we have no easy means to get them from somewhere else. We also don't have the chips. So then they have a strong negotiating position. Say, hey, you want these chips? You want your phones, you want your toasters, your microwaves, your cars to work? You have to come to us. Or you wait 10 years until your new production facility is online, hopefully. Because also for the machines for ASML, just to, that's where it gets really ironic, you need chips for the ASML made machines.
Yeah, exactly. It's a closed circuit.
Yes.
So theoretically, they act now, or they will be useless basically, because later they will decentralize the production.
Well, that's the attempt. That's the attempt right now. That's very young. It's really started end of last year and this year, that they're trying to move production outside of this region. Yeah, that's true.
Just the last question, because you are in the sector, so maybe if you take the people out of the question, only the hardware.
Only the hardware. Okay. What people? What hardware? What you mean for the production?
Yeah. If you worst case scenario, you take all the people working in a fab and evacuate.
Evacuate. Okay.
Evacuate, and you yes, the production stops. But then you make something like a Marshall Plan, and you start the new production in new fabs. Because I think that the people are in the question the most important, because the hardware can be replaced. The people is not so easily replaceable.
Yeah, talk louder. Yeah, it's not so easy to hear back. Yeah, but the question. Let me repeat. So the question is, can there be an emergency plan where all the people from, I guess, Taiwan or South Korea are evacuated, and we take all the brain power and bring it somewhere else, and then revive the production capacity elsewhere? You could try that to an extent, but again, it will take time, because as I said before, like building a factory is no easy thing. And we've only talked about ASML because it's the centerpiece of the machines. It's a long process to make a chip. I didn't talk about everything. And there's a reason why they're so expensive. And it's not easy to replicate and quickly. Because if this is shut down tomorrow and we need to wait 10 years before a factory comes online, and that assumes we have the chips to bring it online, then we're back 10 years in waiting mode. And I think it's going to be, we will see in Russia how that plays out. I don't think it will go well, but we'll see. Microphone? Microphone? Behind you.
We have 1 year of lead time for some devices, for high-end devices.
Yeah.
We cannot waiting for 10 years.
Yeah.
Yeah, when you look at the previous slide where the TSMC factory in the US, it's not really high-end, so I think they want to do...
It's high-end, 5 nanometer.
Currently high-end, but it's not opened yet. And next year we will have 3 nanometers and it still does 5 nanometers, so it's...
yeah, but how...
When it's open, it's old, more or less. And it's also not big.
No.
It has not the product... Apple buys more 5 nanometer than this factory can produce. So it will not even be able to solve Apple's demands.
Yeah. Hold on, I need to correct a little bit. So it's the software mind that's working. Something new comes out, so the old stuff is old. That's not how hardware works. So when you have a fab that does 5 nanometer, and you produce stuff in there, you may have some chips that you bring to the latest stuff, but it's only a small percentage. So if you go back, let me show you.
Yes, it's correct. So there's, I think 5 nanometers the next long-term thing, and I assume this factory is there to serve the US military, so that if China invades Taiwan, the US military can still buy, build high-end chips for their weapons.
But they're not the only ones. The US still has production in the US that's using chips, unlike Europe. So it's not the military is not the only consumer.
But it's really hard to switch from one factory to the another one.
Yeah, exactly. That's what I was going to say. So even though you bring online the 5 nanometer, it doesn't mean once you have 3 nanometer, nobody wants 5 anymore. Because it's not that everybody will migrate to 3 overnight, because it's a long, costly process. So the 5 nanometer will still be used for 95% the next year and 92% the year after. So you can see that even today we're producing 130 nanometer because they haven't migrated to smaller ones because it costs a lot of money, a lot of testing, blah blah blah, and while it works, why not keep producing it? So it's not like everybody jumps on latest stuff all the time. That would be impossible.
You do even new stuff on old technologies. But even when you want to go from 5 nanometer TSMC to the equivalent from Intel, it's probably effort from 1 or 2 years.
Yeah, at least. It depends how big your budget is. And I mean, there are companies that try to go 7 nanometers and they fail, and then they abort. I mean, that also happens. So it's not just because it's simplified. It's not just nanometers, not just the distance, but there are different types of producing chips and how the transistors are arranged. It's complicated, and I barely scratched the surface of this. Okay. Other questions, comments? In the back. Give me the numbers.
In your thought experiment, there was this one bullet which said you burned 100 billions without trying to get anything done, more or less. Why is that?
Why is that? Oh, well, that would be worth another talk. So what I'm talking about here, or referring to, is the Chinese government has, of course, same as the Europeans and others, tried to push chip production, local chip production, and chip design and chip development inside of China. But that's a story on its own. I could do a talk for an hour or two. It's highly entertaining, I can tell you that. It's riddled with corruption, prostitution, extortion, the whole shabam. But basically, you could say the Chinese chip industry is going backwards. They're not progressing. So like in the 2000s, SMIC, so the manufacturer in mainland China, was #3 in global chip production. And now they're distant 5th. So it's complicated. It's a long story, not complicated. It's a long story. It involves a lot of shady stuff, but it's a highly corrupt system And when you throw in money, think of the Russian. Everybody thought the Russian military was great, and they had all these billions that throw in, and in the end we see crappy stuff coming out. Yeah, it's just the same kind of thing. That's the nutshell answer.
Ah, I see, I see. And another question, if I may, is does it matter if these countries or big industry players respect or disrespect intellectual property rights from each other?
It does matter, yes.
And can you imagine that they, because out of desperation, they stop respecting them?
Who is they? You mean the Chinese?
I don't, yeah, probably. I just wonder if intellectual property and sticking to it and sort of not being sued.
The problem they have right now is they can't produce it. It sounds weird, but they can't make it. If you can't make it, what helps you if you have all the blueprints? You can't make it. It's difficult to process, I know. But
yes, checking. Well, this ASML stuff is so intricate that it's not replicatable by any means.
Yes. You see the Dutch guy smiling in front of you. It's really complicated stuff. It's really, that's why I said before, this ASML stuff, it's just one example, is really science fiction. It's on the edge of
even if they have all the blueprints, even if they know exactly what they need to build, then they could not pull it off.
ASML, as I said before, it's big. They have 4,000 or 5,000 suppliers, and like a fifth, 20% of them only build for ASML. You would have to replicate all of that. You would not only have to replicate ASML, you would have to replicate, I don't know, the mirrors and the optics, everything. And it's just, it's an uphill battle. And it's a race. And that's also the problem. Often when I'm in these discussions, people say, oh yeah, but give them a few more years. They will catch up. Yeah, but the problem is at the same time, the rest of the world is progressing as well. So if you want to catch up, you have to be faster than everybody else by yourself. And we don't see this happening right now. I'm not saying it's impossible, but we're not seeing it. And as I said, the problem here is also in the Western world, we are very, well, how to put this? Can you imagine, let me put it the other way. Can you imagine a Mark Zuckerberg in China or in Russia? I cannot imagine that. Like, because he's such a shy, nerdy guy, and if he was surrounded by mafia-type people that are after the cash, he would not survive. That's just how I imagine it. So, like, we have a culture in the West where nerdy people can build stuff and rise to the top. But they can build companies and stuff without having to pay bribes, without having to worry that in a dark alley, you know, hey, where's my share? You have a nice business there. It would be a shame if you had an accident one day.
Yeah, that's what I call a political statement.
Can you imagine what is ASML too big to fail? Can it fail?
Too big to fail. Oh, you asked me questions. We should ask him. Too big to fail? Well, right now there is just no one that replaces ASML. But to be fair, it's really a nice story. ASML didn't exist really 20 years ago. It didn't exist. It was a small player, small company, part of Philips, going nowhere, and they got the right technology. They actually bought the EUV technology they got from the US because the American had a consortium to develop EUV technology for chip production. They developed for 10 years. They threw money at this during the 90s, and they gave up. And then along came ASML and said, I will try. And then they got the license. They were the only ones to get the license. So it's basically an American consortium that holds the license on EUV. And then they got EU funding and EU research support. So the EU set up a program to support ASML to build up chip production capacity and bring this forward. So they also threw money in. And over a time of 10 years, they managed to make it work to a point that nobody else could. And that's where they are. So it's a really nice story. Could there be another ASML? Why not? I mean, given the right people, the right amount of cash, and the right circumstances, why can that not be repeated? But right now there is no one. Right now there is only ASML. End of?
I wanted to
last
ask
question. Yes.
one question regarding Huawei and Xiaomi. I was wondering why were they so aggressive against Huawei and not against Xiaomi? Is it because Huawei did something specific, or why? Do you know anything about
Well, I was not in the rooms when the decisions were made. I have to say, even though I sound very official here, I was not there. So I can only share my thoughts, basically. Don't take it for what it's worth. You can do your research. I think that there are a number of reasons at play. So one is the Americans were annoyed with Huawei for a long time because there was a lot of IP theft going on and a lot of hacking and stealing and circumventing sanctions. The US is very, picky. If you circumvent sanctions imposed by the US, they remember that. And they brought equipment into Iran and stuff, and I don't think that went well with the backroom people in the US, whoever made those decisions. And of course, there's also the technology side of things. Every now and then, the US likes to remind some countries who's boss. And the Chinese are very proud of Huawei, and it is an achievement. I mean, they've built a company that is internationally known. It made good products, whether the technology was stolen or all that apart. So they're proud of it, and rightfully so, I think. So it was also a good object to slap on the wrist, if you will. So I think there are a lot of reasons at play. Maybe more that I'm not aware of, but those are my most convincing reasons that I've heard of him.
Just to give you a little oversight, the Huawei routers, so the enterprise-grade network devices, the command line is mostly one-to-one the Cisco iOS. And when you touch Cisco, particularly to the Americans, is one of the, as you say, proudest company exporting technology in the world. There was literally a clear IP theft because you can use the same command on Cisco on a Huawei router. And maybe this one is one of the reasons why they targeted Huawei. At least Xiaomi, yes, is acquiring share of the mobile market, but the product seems to be genuine. They are not copied by someone else. Because one time I had to access on a Huawei router, and it's, oh my God, it's a Cisco router. You can see no differences on the technical level.
Okay, thanks.
Correct break, okay. Cosmico.
You have. Okay, I didn't see it on the black shirt.
It's mimetic with microphone. Okay. 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 This presentation is show you my first experience using DSA, and like a user. So I'm not a developer. So I'm a user. I was a user with a problem. So have to study something about DSA to resolve my problem. So that during the lockdown, I decided to buy a new router, and I'm start from a commercial router that is inside the implementation is like this. So we have a CPU. It's a connection between the CPU and the switch using VLAN, and then I have two managed switch, and I perform two trunk to the two managed switch, and I decide to change this this router. Okay, when we configure the router, we use IP-route2 bridge control for interfaces, and switch config to configure the router, and the web or the console to configure the managed switch. Okay. What's different in DSA from the previous? That we want to see a remote port of switch as a device at the CPU level. In previous configuration, we see the VLAN. Then the configuration of the switch permit to describe the behavior of the switch of these ports. So in this way, we don't use the VLAN packet 800.2.q, but we use another Ethernet type. So we use another protocol, a layer 2 protocol. We use different buses for control plane and data plane, and so we can substitute the VLAN packet with this one. With this one, it's a quite different to the VLAN one, because also the Ethernet destinations and sources, we have the replacement of Ethernet type with that tag, and we have these fields. That is the protocol encapsulated of Ethernet frame. For example, we have mode, for example, switch device, switch port, VLAN ID. So with this packet, we can decide at the CPU level where our packet is directed to, which switch, and in which port you have to do. It have to exit, sorry. The direction from CPU or to CPU, and if one of these flag is 1, I don't remember which one, if the packet is tagged or not. So we have the payload, that is the payload of our data. In this case, okay, so, sorry, the architecture that is well described in this paper from where I take this picture. We have the CPU, the Ethernet MIC, and so the red one is the DSA flow. DSA flow where that packet is propagated and arrives to the switch declared in the fields, and the behavior of that packet that have to exit and from which to which port is described there. So my problem was, can I use my managed switch down to DSA1? Yes, because if you see the packet, it's possible to declare the VLAN ID. It's possible to say to the packet to exit tag it. So in theory, it's possible to do that. if I see the documentation of Openwrt DSA Mini-2, we have these interfaces. It's so similar to the interface of switch config, so you can generate the configuration for the switch, but is applied to a bridge. So this is the, how we say that, this is the port, the exit port of the switch. And it's possible here to say, okay, for VLAN 1 is untagged, 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 and so on. Like the configuration of switch config. The router that I bought was Omnia Turris. This is an internal connection from the CPU to the switch. So we have three interfaces, two connected to the switch, but the LAN 6 is directly connected to the LAN 4 by, I mean, a internal configuration, and LAN 5 to the other one. So we have Ethernet 2 with one port. If we show the IP link, we see the reason of previous discussions of the patch of 2 lines, that LAN 0 is back on ATH0 and so on. LAN 4 is behind ATH1, and ATH2 is no DSI port, is directly to WAN. So when I see Openwrt documentation, also LAN 4 is behind ATH0, probably for different configuration of this switch. This is the switch inside the Omnia Turris that the switch support DSA, and in the version 5 of the operative system that's derived from Openwrt, uses the DSA. There was a version, I don't remember, 4 or 3, that it used still the VLAN for the communications. But TurrisOS version 5, the current versions, is based on old version of Openwrt, so there is no bridge VLAN filter implemented. So this problem, how I can connect my managed switch to this version of the firmware of the router. So we have one router. We have attached 2 switches on LAN 0 and LAN 1, for examples. For example, we have two VLANs, Office VLAN 0, Home VLAN 100 and 200. And for example, we want LAN 2 an access port for Office, and LAN 3 an access port for Home. And switches are connected via trunk port. So we have, I want to do the same layout of before. So I want two trunks, two access ports, and then behind the switch I want some ports of VLAN 100 and one port 200. How to do that without that support? It's a little trick that I found out, and so the solution is encapsulate VLAN packet in DSI packet, and so don't use VLAN information in DSI packet. using these two tricks, it's possible to do the same work, but I know that is an overhead and a CPU load, but it permit me to work with this router. How to do that with command? I have created a bridge, and then I create two VLAN of this bridge. So I put inside the bridge the two interface, the two devices, and then I create another bridge that I call office, when I put inside LAN 2, this is an access, and a VLAN of this bridge. The same for home. I create the bridge home, LAN 3 and brtrunk.200. And this is, for example, the screen of my on my router. This is the interface brtrunk that included. This is I use another port against the example. So I have two trunk on LAN 3 and LAN 4, and the VLAN, the access LAN, okay, BRLAN, I have the port, and it's included a tagged trunk. What happens? That all packets are processed by the CPU, are not by the switch in communication between two ports of the router. So it's not the best performance, and of course I waste the bytes of the DSI packet that I don't use because I have encapsulated a VLAN packet and not an Ethernet packet inside the DSA. So after these brief presentations, we're waiting for TurrisOS version 6 that is based on this version of Openwrt that included this facility to manage correctly to track correctly the packet DSA using the switch. So I think that we will find more and more devices with this kind of switch inside. So and like you see in the previous presentation, more and more devices switching using DSI protocol instead of VLAN. So Cado? Okay. Oh, okay. That's all. If any, tomorrow will be a presentation of our colleague that we show in deep also the implementation of DSA, and we also have a guy from Turis that probably show us more about their firmware. That's all. Any question? Okay, thank you.